Sorry, I missed out something here. If the relation maps all right, so this is our example. So it says if the relation maps x to x plus 3 for the domain negative 2x to 3, draw the graph of the relation. All right, so you might be saying, boy, what all of this mean? So basically, what we're going to do is to, first of all, can anybody explain what this means? Negative 2 less than or equal to x less than or equal to 3. All right, so basically it's just x values that starts at negative 2 and ends at what class? What do you think it ends at?
Positive 3.
Positive 3. So after negative 2, what will come next?
Negative 1.
Negative 1. Then what?
0.
Mm-hmm.
Positive 1. Positive 2. Positive
And 3. All right. So whenever you see something like this, it just means all the integer values that lie within negative 2 and 3. All right.
Sir,
so, yes.
What if there was just the less than and the less than sign without that equal below it? Would I still include those values? Would it negative 2 be included? I don't know if the students have that question. So we have to look at our inequalities carefully. So if we just had the less than without that equal below it, then we would include those end values.
Right.
Yes, and this is a concept that is tested on the multiple choice at times, so we have to ensure that we know about it. And if you have a follow-up question, you can ask now if you're not sure what I'm saying.
All right. So basically, what Mr. is saying is, what if the thing never look like this? What if we have something like this? Instead of having less than
positive numbers.
No. What if it look like this? What she's saying that you wouldn't include the negative 2 nor the what? The 3. That's what she's saying. All right?
Yes.
Is the meeting recorded?
Yes.
Okay, all right, good. All right, so first of all, what we do, we set up a table. All right, because the question says to what? To draw a what? A graph of the relation. All right. Right. So this is the mapping relation. So x maps to 2x plus 3. All right. Now, in any graph, we have a set of x values, and we would have a set of what? When you join a graph, a set of what?
Y values.
Y values, not true. So we can, is it all of this right here, so? All of us something right, so we can actually call all of that highlighted part y. So basically what we're going to do, we're going to input the x values in this relationship, and we're going to get a corresponding y value. So for example, you're going to say, all right, when x is equal to -2, y will be equal to, so what we're going to do, we're going to input x value in this relationship. All right, so it's going to be 2 multiplied by what? By x. But what is x?
-2.
Right. Plus what? 3. What the following so far? Any questions?
Not necessarily,
All right. And 2 times -2 will give us what, class? -4 plus 3. All right. And what's -4 plus 3, class?
-1.
-1. So basically, when we input x equals -2 in this relationship, we get a corresponding y value called what? -1. All right. So what I want
Sir,
to
question, sir. Can you get -4, sir?
all right. Okay, so we're using this. All right.
Yes, sir.
So 2. What does 2x means? (2x) means 2
2
multiplied
times x.
Right. So what I'm doing, I'm replacing x with -2. So 2 times -2 will give us -4. All right. Any questions? All right. Can you guys? I'm going to give you 3 minutes to fill out those blank spaces. All right. So the next one would be what, class? The next, you're going to say when what? When x is equal to what now? -1. What is the corresponding y value? So we're not going to input -2 in this relationship. All right. We're going to input what? -1. All right. So you'd have something like, you start out with something like this. Rather than having -2, what do you have, class? -1.
-1.
All right. So I'm gonna give you guys 3 minutes to finish that. So then can you just call on various students when the time is up to let them
Tell us what the corresponding values are.
just randomly ask students.
Okay.
Yeah. Want
So
you guys to work.
All right, sir. So I'm just connecting the definition to what we're doing here, because the definition says a relation is a set of ordered pairs that obey a particular rule. So the rule would have been the equation that sir gave us just now, that particular function, right? And it says that x is mapped onto 2x plus 3. So the rule that we're using is 2 times x plus 3. So we must obey that rule in order to generate those ordered pairs. So from the table, or what we're doing now in the table, is to create those ordered pairs. So once we input the x values given, we end up with the corresponding y values. And the x values in this case, there's a unique name for them. They're called domain values. All right, so let's hear from Lola. Lola, what do you get for the y value when x is -1? Lola, everybody should be working.
+1, miss.
All right, so Cardita got +1, sir. All right, so let's hear from Maury. what is the value, because you should be doing all of these, you know, so you're using each x value. So Maury, what do you get for the y value when x is 0? Before you answer, Maury, sir, can we confirm the positive one? She's correct, right?
All right,
Yes, let's confirm it quickly.
all right, so 2 times -1 is -2.
Mm-hmm.
-2 plus 3 is 1. Yes, correct.
Nice. So Maury, moving forward, when x is negative, when x is 0, sorry, what is the corresponding y value? Maury? Lola says she's not seeing the screen. Let me see if I need to pin the screen. No.
Probably our next. It's not so good.
Lola, you should, because it's pinned. Maury, what do you have? Oh, I mean, pin. Lola not seeing the screen for you. Oh, but it's a screen is pinned. All right. Maury, what do you get for the y value? Not sure if Maury is hearing me. Let's move on. Tiara, what do you get for the y value when x is 0? Tiara Clark?
Miss, I wasn't working it out because I had to step away from the device.
You can work it up now, darling. It won't take you long. So now we're using x to be 0. We're still using the same rule, the same function, the 2x plus 3. That's the rule that we're using. So now you're told that x is 0. So you're just to input that 0 wherever you see x, and then you simplify. What do you have? Simon, what do you have? Mr. Stevens, I figure that maybe, you know, some persons join, but one, they're not at the device.
Excuse me, Miss. Can I try, Miss?
1 minute, Sidela. Sir, I'm assuming that we might be wasting our time, you know. So it seems as if some persons are on, but they're not at the device, or they're just sitting and looking at the screen.
All right. Students, remember, you know, mathematics is an active subject. It's not a listening thing. It's something that you have to get up and work. Right? It's not a discussion. We're not discussing slave trade or social problems in society. It's an active subject. All right. All right. So let me.
I see a hand. Sidela, Sidela, you can go ahead and try.
3, Miss.
Okay.
Very good.
Mr. Stevens.
Correct. Awesome.
Nice. When x is 1, Natalia, could you say what the value of y is, Natalia?
When x is 1, y is 5.
Awesome.
Nice. All right.
Very good.
Keandre, could you say what the value of y is when x is 2?
7.
Awesome.
Right. Davina, could you say what the value of y is when x is 3? Giovanni, could you say what the value of y is when x is 3?
So maybe you don't want to speak in class. You can also message your answer.
Go ahead, Cardelia.
9, Miss.
All right.
All right. Very good. Very good. All right. Okay. All right. right, so don't feel intimidated when we call upon you here. Probably next time we should say persons who want to volunteer. But, all right, so thank you so much. It's pretty simple, you know, guys. You just replace these values with x, you know. So, for example, the last one, 2, 3 is 6, 6 plus 3 is 9. Pretty simple. All right, so I'm not gonna spend the whole time on working on those rest. All right. Is anybody not following? Anybody want to explain anything before I continue?
Sir.
Yes.
So whenever we get a question like this, we must always look out for the part with the less than and equal sign. That part as well.
All right. So what you need to look out for really is everything. You know, usually in these questions, what you should look out for mainly is the starting number and the end number. Because for example, suppose this was 0 and say 6. You're going to start out with which number? 0 and end with what? 6. All right. The usually for these questions, you look for the starting number and the ending number. All right. And usually they will give, let me tell you what they will do in CXC. They will give you all of this. They will draw the graph for you. And what they'll do, they'll put in some of the answers for you and say, okay, find 2 of these values. So the table would have been there. And for example, the 3 would have been missing. And let us say the 7 would have been missing. And it's a fill in those, work out those 2 values. And you get 2 marks for that.
Mm-hmm.
All right. All right. So as Ms. Hilton was saying, there are special names. Now, would you guys agree with me that the x values, right? So the x values are -2, -3, -4. Oh, Lymantel, sorry. -1, 0, 1, 2, and 3. All right. So, right. So is it all x values? All x values are called. What are they called?
Domain.
Domain. Right. 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 So the x values have a special name. They're called domain.
Excuse me, sir. Is the Y values called range, sir?
Right. Right. Very good. The y values are called their range.
Or in some cases, sir, we may see codomain, correct?
Yes. 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 Codomain. So they are called range.
Mm-hmm.
Or is it one word?
Yes. And these are just some scientific terms, nothing for you to worry too much about.
All right, so let's get to the definition, class. It says a relation. Oh my! I forgot one thing. The ordered pairs.
Mm-hmm.
What are the ordered pairs, class? It will be these values here: -2, -1. So that so the -2, -1 will be a pair of coordinates, and then we have what? -1, this -1 here, and that +1.
Mm-hmm.
All right.
3.
Right, etc. Yeah. Let me just do the last one.
Yeah.
Or camera do all of that.
Mm.
So all of these, when I put them together, they call a what? An ordered pair. All right. Let's get to the definition now. It says a relation is a set of what, class? A set of what?
Ordered.
Right.
Ordered pair.
That obey a particular rule. No, the rule I'm talking about is this mapping rule here. So,
Mm-hmm.
all right. So the rule is like a set of instructions. All right. So think of it like a factory that is making say ketchup. All right. What these engineers have to do, they have to come up with a formula to tell the computer how much tomato paste, how much water, how much spice to go in the thing. All right. So it's a rule. It's like a input. You're inputting you're making something. So that's what it means. All right. For example, you're making syrup. There's the computer. You need a specific rule to input in the machine to make it. So the rule can be different, dear class. The rule can be different. All right. So that's what the definition of a relation is. All right. Now, another important point is that we can represent a relation on a mapping diagram or a graph. All right. So a mapping diagram really is pretty simple in this case. So it's like
connecting the points, the pairs basically.
Right. So let me just quickly sketch
Yes.
what this is. So we can represent a mapping diagram. So we can represent a relation on a mapping diagram. So a mapping diagram is like this. It's like you have two
like a mapping thing, like.
Right. So we have x over here, and you put in the x values. And then we have the corresponding y values over here. Pretty simple. And then you just connect them. And we have different types of mapping diagram. This mapping diagram is called a one-to-one mapping. All right, it's called a one-to-one mapping. So what you notice, class, we just represented a relation on a what? On a mapping diagram. All right, now we can also represent this relationship, all right, on a graph. All right, and I know you guys can draw a graph. All right, so this, anybody writing this? So this is a mapping diagram.
Any questions? Any concerns? I know the name may be strange to you, but when you see what was done, I mean, you may be wondering, that's it? Yes. So you're basically just aligning the points to their respective corresponding component, basically. So you're matching up the x's with the corresponding y's. So just as though we have them on the table, or just as though we have them in the ordered pair, that's how we connect them. Natalia, you have a question?
I want to know what is the purpose of the mapping diagram.
All right, good question. So as I said before, the mapping diagram is it the information on the table here? That information here? Right. So we can represent, all right, let me ask a question. In statistics, when we collect data, what do we do with the data? We represent the data, not true?
On graph.
And we can represent the data on different statistical diagrams. Morning. Right. So the purpose of the mapping diagram is really to represent the relationship or the table. All right. That's the purpose of it. But we also mentioned that we can also represent the relation
on a graph.
On a graph. Right. So we're gonna
just showing the connection between the domain values and the range values, basically.
Right. So where am I? All right. So the graph now, class. I'm gonna quickly sketch this graph. All right, and please be quick too. and we're gonna soon come up for the review. And we're gonna start answer some questions, right? Okay, now how do we represent this on a graph? All right, so basically on your graph, we have our X value. So I'm gonna draw this because Sir is the best artist. So those lines. All right. So
Which one of the artists?
boy. So we have 1, 2, 3, 0. All right. And can someone tell me which axis is this called? This one here. What is it called?
X-axis, sir.
X-axis. Very good. Can somebody tell me another name for the x-axis? It starts with H.
Domain.
You have a point, you know. The x values are on the x-axis, and the x values are called the domain. You're kind of correct, but that's what I'm not. That's what I'm not looking for. It's a horizontal axis. Very good. So another name for the x-axis is the what? Horizontal axis. And up here, so we have which axis? The y-axis. And what's another name for the y-axis?
Sir,
Hmm?
what she would have answered, she answered what is represented on the x-axis, the domain values, but
Right.
yes, that's not the name for it.
Right.
So I'm hoping Devina made the note just now, because at times CXC might use horizontal instead of x-axis, but they're referring to the same thing. So it's important that you know the terms.
All right, and this is the y-axis. And can someone tell me another name for the y-axis? Starts with V.
Vertical.
Right, vertical. All right, so this is our first point here. All right, so when x is -2, so this is x. This x equals -2. Okay, so I'm in the staff room. So if you're in the other background noise, it's not me here. So x is -2. And y is -1. All right, just for information purposes, all of this, your graph, your entire graph is called a Cartesian plane. All right, it's a platform basically. It's like you have Google Meets and Zoom and whatever. That platform. So this platform called graph is called what? The Cartesian plane. All right. And this is what I call the first quadrant. If you notice, it's broken up into 4 parts. It's called the first quadrant, the second, the third, and the fourth quadrant. All right. Now, in the first quadrant, all the x and y values are positive. You notice. All right. So in the first quadrant, all the x values are positive. But however, on the second quadrant, what happens on the second quadrant, class? The x values are what?
Negative. Negative.
But the y values are what?
They remain positive.
Very good, right. And in the third quadrant, what happens?
Negative.
Both, right, both x and y are negative. And in the fourth quadrant, x is what?
Positive.
Positive, but y is negative. Awesome, very good. All right, so what we're planning to do here is just to plot this point here. So remember, whenever you're plotting a point, class, the first value is always the x value. So x equals -2 is, so you look for x equals -2, but y is -1. So, oh dear, this thing here kind of
it's jumbled.
Yeah.
But yes, sir, we're covering here, sir. You know, if these students pay attention, this can help them with other questions.
Other questions, so many
Yeah,
questions. Let me be very professional. Let me do the thing proper for you guys. I'm bringing up a software that can actually draw this thing properly.
Any questions while sir get the software up? Don't be afraid. Don't consider your question to be stupid. If you want clarity, just say something. And remember, we're being relaxed. We're not rushing you because we know you have a lot doing and thinking about. So just pace yourself. And if you have a question, type it if you don't want to open your mic.
Mr. Hilton, remember the equation again. Is it y equal, is it what? 2x?
2x plus 3.
All right. So as you can see, all right, I am unable to show you the entire thing. So I'll show you part. So as you can see, this is our x, our horizontal, and our vertical axis. So the first point was negative what? 3. Was it negative 3 or negative 2?
Negative 2 and negative 1.
Negative 2. Okay. All right. So it's negative 2, negative 1. So as you can see, this is negative 2, right? And it's negative 1. So that's our point there.
Mm-hmm.
And then we have negative 1 and 1. See that?
Mm-hmm.
And then we have 3 and 0.
Mm-hmm.
And class, remember that anytime
No, sir, that was 0, 3.
Oh, 0, 3.
Mm-hmm.
Okay. I was just testing you guys. See if you testing you guys. So this is 0, 3.
Mm-hmm.
1, 5 and,
Mm-hmm.
and 2, 7, and I believe 3, 3, 9 is somewhere up here, but you kind of cut off. So this is how we plot a graph. All right. So we just represented the relationship on a straight line, and sorry, on a mapping diagram, and also on a graph.
Mm-hmm.
All right. You guys want to sketch this quickly? So this graph is called x maps to 2x
Plus
plus 3.
or y equal
Right, or y equals 2x
plus 3.
plus 3.
Nice.
And you might say, boy, oh, this game helpful. Let me tell you something. You see, everything in computer graphics started off with this, right? All right. Computer graphics. The reason why you can do anything on a computer with any line, anything at all, any animation, the foundation of animation was started with coordinate geometry. So if you want to become want to work at like Disney Studios, animation studios, or Pixar studios, and you know, these are things you're going to learn. All right, let's try to wrap up the overview because time is going. All right, so we said that we can represent a relation on a mapping diagram or
Graph.
on a graph. All right. Now let us be specific now. Now we have different types of graph. So we have different types of, I would say different types of, let me say relations. All right. Now this particular relation, so this particular relation This particular region is called a straight line. All right? Or it could be a linear function. No, I know we haven't started function yet, but what we're specifically looking at is what? A straight line graph, because we can also get curves. All right? Now, please note, all straight line have a general format or look. All right. So, for example, when you see a police officer, you can know he's a police officer. Apart from the gun, but some of them have some different uniform, but you just know it's a police officer. So you would say, boy, all police officers have a general look, you know, all doctors have a certain look, you know, etc., etc. All right, so all straight line have a general look. All right, and this general format is called so the general format is y equals mx plus c. All right, now x and y represent the variables. All right, so remember the table. So right, so in this general format here, the x and the y are the variables. What variables? It's just these numbers here. They vary. They can be any numbers, right? Right. So x and y represent the variables. Now
the x's are the independent ones, so we need
Right.
those in order to progress to the y. Cardelia, have a question, sir.
Okay, go ahead, please.
Mister, I really want a question. Sir, you put any instead of and.
Okay. So, thanks, Cardelia.
Come on. All right. So now x and y represents the variables. Now m represents what we call the gradient. All right, or slope. All right. So the British use gradient, but if in America they use slope. It's the same thing. All right. So m represents the slope. Now m can be positive or m can be negative. All right. Now when the m is positive, the line falls to the right. Otherwise, it will fall to the where?
Okay.
All right. So if the line is falling to the right, by the way,
We're going up the hill. We're going up the hill.
right. So look at this line, class. Is the line falling to the right or to the left?
Left, sir.
Really?
It look like the right
Yes.
to me, sir.
Right.
To me,
All
I'm
right.
a left, miss. So
No, all right, hold on.
We are all facing the
my,
device.
my left are your.
No. We are all facing the device. We're all seeing the same thing.
I see anything as a man.
Look at it carefully. We're all seeing the same thing.
Imagine that line is a line stick. That you hang up close. It's a line stick, and you hold the line stick like that in front of you. Where would it fall? Would it fall this way?
Oh, where were they pointing to, sir?
All right, I'm not getting that. All right, so but the line, if you hold a line like this, a stick, a line stick or a bamboo, like in that position, it will fall. It will definitely fall to the where? To the right. All right. Right. Suppose you hold the line stick like that. Where would it fall?
To the left. Oh,
to the
that's
to
a
the
mean.
left. It will fall to the left. No, because the line is falling to the right. What is the gradient of this line? Is it positive or is it negative?
Positive, sir.
It will be positive,
Positive.
right? Right. So you can know how the line can look if it falls to the left or the right. So if the line is falling to the right, it means that the gradient is positive. If it's falling to the left, it means negative. Quick question. Suppose you hold a line stick like this, up in the air like that.
Vertical.
Yeah, suppose you hold a line stick like that. Where would it fall? Or what would be the gradient? If you hold a line stick like this. I mean, to be frank with you, what's going to happen? Thank you, sir. Very good. So when the line is like this, the gradient is what? 0, because we don't know if it's going to fall to the left or we don't know if it's going to fall to the right. So the gradient is equal to 0. Let me tell you how useful gradient is. I don't know. There was a time in Jamaica when the member of parliament that is visually impaired, can't remember his name. Anybody know his name? The visually impaired is on the PNP side. Right. Senator is it Floyd Morrison. Right. So Senator Floyd Morrison is a visually impaired senator, and some years ago he would have made some representation as it relates to persons who can't walk, persons who are in wheelchairs. All right. And what they're saying that every business place must have a ramp to facilitate persons in wheelchair, right? And what happened is that so a law was passed, all right. But what happened is that some business places they were making the ramp too steep.
Mm-hmm.
They were making the ramp. They were sometimes they didn't even run it on the road. They weren't making the ramp correct.
Mm-hmm.
So what happened? There was a problem. All right. And you know what happens when the ramp is too steep? It might run off or something like that. So in other words, the slope of the ramp or the gradient of the ramp was causing the problem, or how high or how low the gradient is.
Mm-hmm.
So then the parish council come into play and they set up standards and regulations of how to build the slope or this, what is the slope. So it goes to show you how mathematics is very important in some of the things, especially in constructions. All right. So these are some practical applications where you guys can relate to. All right. All right. So having said that, let's continue. So as I was saying, M represents the gradient, X and Y represents the, as Ms. Hilton says, the independent variables.
Y independent and dependent. So Y would be dependent. Mm-hmm.
Mm-hmm. You know what? Okay, so X will be the independent,
mm-hmm.
and Y will be the what?
Dependent.
All right.
Mm-hmm. And if we are dependent means, we need something in order to function. So in order for us to have the Y, we must have an X, hence the X is considered independent. Like we are, we don't need anybody. We contribute to somebody else. So the X is independent. The Y depends on the X. In those words.
You find that other ladies like to say independent.
So we are sorry.
All right.
Yeah. I don't like what they're say we are X's, but no, I don't like that. Yeah. We are independent. Okay. I'll just use that word.
All right. Okay. All right. Okay. I just see the real joke there. Anyways, so M represents the gradient or slope. So M can either be positive or negative. All right. I'm gonna talk about left. All right. Now, last point. C. So C represents the intercept on the Y axis. All right. In other words, look at this, class. Can someone tell me what number the line cuts the y-axis? What number?
So you can maybe I was just gonna tell you to label them A, B, C, D, E, F, or straight up to E, and they could tell you the letter.
Okay.
Maybe that would be easier
so-
for them. But you circle it.
Okay. So if you notice, the line cuts the y-axis at what? What number?
3. Negative 3.
3. So therefore, C is equal to what? 3.
3.
You get that, class? All right. So let me share something now. Let me share something. We're gonna finish the overview because it's an overview come like on lecture. All right. So what you know? We said that y is equal to mx
Plus C.
plus c. All right. So now, guys, you realize that c is 3. So y, we could say y is equal to, we just find when I let them know, y is equal to mx plus 3.
Mm-hmm.
All right, because I can give you a line, and say, okay, from the line, tell us what is the equation. All right. Now the gradient is a formula for gradient. All right. So gradient.
We're the physicians, sir. They know about that.
Y2.
All right.
The rise. I was referring to the rise and the run.
All right. Yes. Well, what he's saying, the y2 is also correct. But
Yes.
let's start with something simple.
Mm-hmm.
All right. Now, so the gradient. By the way, can someone tell me what the form of a tangent is? Anybody know? So-called tor. What is tor?
Opposite over adjacent.
Right. Opposite over adjacent. Now, the mathematicians they defined slope as tangent. That's how they got the formula from. So basically, it would have been the rise. So gradient is rise. And when I say rise, I'm talking about vertical rise and horizontal run. All right? But really and truly, they got the gradient formula from the tangent formula. All right? So what am I talking about? What you're going to do is to just draw a right angle, a convenient right angle triangle. So let me just do something like this. So let me just do this. See that? I'm drawing a right angle triangle. See that? All right. Anywhere on the line.
Nice. Anywhere.
Anywhere. As a matter of fact, let me just say this. The gradient of a line is the same right through anywhere on the line. So you can draw a triangle anywhere you feel like. You end up with the same answer. So this is my right angle triangle. All right. So what I'm gonna count the rise now. So the rise would have been going up like that, and true. All right. So it's vertical rise. So let's count it now. 0. So you ignore these numbers and it says 0, 0, 1, 2, 3, 4. So the vertical rise is 4. So rise is equal to 4. Sometimes when I'm, I usually, just being playful, I just say rise. So, and then the run would be going that way. So it would be 0, 1, 2. So the run is what? 2. So it's 4 divided by 2. So 2 into 4 goes what? 2. So the gradient class is what? 2. Now question, is the line falling to the right or to the left? It is falling to the right. So therefore the 2 must be what?
Positive.
Positive.
Right. So I'm almost finished now. So the finished product is what? Y is equal to positive 2. So you don't write the m. You replace m with the 2. It does work out. Mx plus what?
3.
Right.
But
So
sir,
this-
I never got the equation and give in the question.
Exactly. So remember, So this, remember, class, we initially we started off with this, the same thing.
Oh,
X
so
plus
this
3.
is how it came about.
Right.
Nice.
Right. Very
Nice.
good. So we start off with the relationship. We draw the graph, but what we just did a while ago is to use what the graph and do the reverse to get that original thing.
Oh,
All right.
interesting.
Right. Yeah, man. Very good. I'm gonna show one more interesting thing before I do this long overview. Let me show you something, class. Suppose I say, suppose I say. Oh, by the way, just for information purposes, as I was saying, how tangent is involved in this. Now, this angle here, right? This angle. Can someone tell me what this side is? It's opposite the right angle. What's it called? Starts with H.
Hypotenuse.
Hypotenuse.
Right. And the angle between the reference angle and the right angle is called what? Starts with A.
Acute. Obtuse.
Adjacent.
Yeah. I chew one upstairs. I don't know. One's upstairs. Upstairs. All right. And this will be the opposite, don't you? All right.
Yes, sir.
Right. So guess what? What is tan? It's called tor, right? Tan is what? Opposite. So the opposite wouldn't is, do you guys say it's the right? It's still the rise, and the run is what? A. Right. So you see how tan and gradient is all connected. I'm just want to show that point. All right. One last point. Suppose I say, I say, all right. Look at this question. The point. Look at this question. The point. Remember in class, we had to use these points to plot the line, not true? All right. But what if? Let me just say, all right, hold on. Let me just copy one of the points. Let us look at 2 and 7. All right. Watch out. So we know so we use 2 and 7, right? Suppose I put this question to you. The point call it 2K. The point 2K lies on the line. It lies on the line y equal 2x plus 3. All right. Find the value of k. Find the value of k.
I love this question.
All right. So what to know?
So I wonder if anybody in the audience can tell us what they would do quickly, how they would go about it. Because we spoke about ordered pair today, sir, and everything. And it says that that particular point there is found on the line given. How would you go about calculating K? Let's hear from Devante and then Devina.
Miss, I would replace the x with 2.
Mm-hmm.
And then you're the solveness. So you're the times the 2 with the 2 after you replace it. So you get
Awesome. Very good.
and then plus it with it 3, I get 7.
So when you get the 7, it is saying y. So can we just use that and say y is K? Like, what explanation would you give? Not sure?
Not sure.
All right. Nice. Devina, you're in agreement? Sorry, sir. Devina, you're in agreement?
Yes, miss.
So how do y connect to the K now, Devina? What would you tell us?
Miss, since they said 2 at a x, it 2 the x, so we get the 7 for the answer. But then say a 2K, you know, miss. So we go have to go for the 7 and put the dot there and say K represents 7.
Awesome. So you say, so I think I get what you're saying here. She says, sir, the x, the 2 would be x, so naturally the K are y.
Right.
And the system that we have with other pair, x, then y. So I'll say x, you could have used p, q, r, x, t, u, v. We know that we have x value first, then our y. Take it away, sir. I like that.
Yeah, man, very good. So basically in the class, we know say k is equal to 7, you know, because I'm telling you, all right? Because we know that we use 2 and 7 to draw the line, but let us say we never know say k was 7, all right? And this question is presented to you. The point 2k lies on the line y equals 2x plus 3. Find the value of k. All right, as the young man rightly and correctly said, that what we do, we just replace those values. So we know that the first number in a coordinate is x. So we use this relationship, all right, and replace x equals 2. But if x is equal to 2, what is k equal to? What second number? What is the second number called? What letter? Which axis?
Y-axis.
The y, right? So in other words, we say x equals 2 in the equation, and we say y is equal to k. All right. So then now I'm gonna use this thing here now. So if I'm using y, so I'm not gonna start off with y because I say y is equal to k. So k is equal to 2 multiplied by x. But what is x? 2 plus 3. All right, and that's how we get to 7. So k is equal to 7. All right.
So we could still use the y, and then at the last you could say therefore k is 7.
Therefore, k is equal to 7.
Yes.
And in class, I could switch around the question. You know, I could say I didn't have to say 2k. You know, I could say what?
K
k2. Suppose it was something like this, class.
or k7.
Or k7. How would you approach a question like this now? I switch it around. It's not 2k. It's
So you
k2.
replace the x with k.
Very good. So x is equal to what? To k. And hold on. All right. And by the way, class, you realize that I don't have to use k. I could use any letter in the alphabet. I just convince
And y
them.
is 2, sir?
Right. So x equals k, and y is equal to 2. All right. I want someone to tell me what I'm for right now. I'm using this now. So what am I gonna do now?
So you're gonna say 2
Right. Because remember, class. Right. Class, remember.
Write it back over there, sir.
All right. Yeah. You know. Yeah. That's let me. So I have y equals 2x plus 3. Right. Go ahead, no bossy.
2 equal 2 times k,
which is 2k
plus 3.
plus 3. All right. So we need to find k. I need somebody to tell me how we solve for k. It's a simple linear equation.
Divide both sides by 2.
So replace y with the 2.
All right, hold on.
Sir, go take out the k.
No. All right. Hold on. No. All right. Yeah. Well, look. We want k, not true. But
Yes,
we can't.
sir.
We're not gonna get rid of the 2 first. We have to get rid of something else first before we get rid of the 2.
Sir, get rid of
The 3, sir.
the 3,
The
sir.
3. Right. And how we get rid of the 3, class?
Yeah, minus 3 from
Subtract it,
sir.
sir.
Minus
On
3,
both
sir.
sides.
Right. I thought someone said uproot it. All right. So that joke didn't work. So 3 from 3 gives 0. So we get 2k. What is this, class?
-1.
Right. And what do I do now?
Divide both sides by -1.
No, man.
No, 2.
By 2.
By 2.
Take up your book, please.
And so k, the 2 cancel. So k is equal to -1/2. It's a lot. It takes a lot more effort, you know, when it's on the left hand.
Mr. Stevens, you know what I love about mathematics, and I always say it's not a selfish subject. What I mean by that, the concepts are so connecting, because here we are doing a different concept. However, we're using rules that we know before. We did this in algebra. Don't leave the skills. It's the same thing. We may start off the question differently, but the skills, the techniques that is required to answer, the techniques required to answer is something that you know before. So just as Sir said, relax yourself. If you see maths, though you're working with time, if you start rush up yourself and get anxious, your brain will get mixed up. Just relax and think about it.
All right. So, do we have any questions? All right. So, Ms. Hilton, I just remember that I need to mention 2 more points. Because remember, as we were discussing yesterday, this thing won't take a lot. So I need to mention 2 more points. All right. So, and then we're going to go to a past paper question. All right. So,
Sir,
yes.
excuse me, are we draw the line sometimes or?
Yes. Sometimes you're required to draw the line, and sometimes the line is drawn. All right. Yeah. But in the case where
So we just draw it straight through the points.
yeah, that's right. So you'll have to set up a table. When you set up the table, they'll give you the X values. You work out the Y values, and then you go on the graph and you punch in those values.
Plot them.
You plot them. Yeah, not punching them. You plot them.
We get so technological. Like,
Yeah. All right. So 2 more small points. Well, big points actually. So when 2 lines are parallel, all right, they have the same gradient. All right. All right. So in vectors, you know, in vectors, when 2 vectors are parallel, one vector is a scalar multiple of the other. So the definition in vectors is a little bit different. So when 2 lines are parallel, class, they have the same gradient. All right. So when 2 lines,
So you can give 2 examples. Give an example here in the definition, like 2
all right.
lines.
Okay. All right. So let me go to the GeoGebra. All right. So let me show you what a parallel line looks like. All right. So y is equal to 2x plus 5. Right. That. So what I had before was 2x
plus 3.
Plus 3. Not true. This is y equals 2x plus 3. But now we are drawing y equals 2x
plus 5.
Plus 5. So you notice the m is the same, not true? And the lines are what? Parallel. It's just that this one cuts at 5 and that one cuts at what? 4.
Yeah.
All right, class? Right. That's how a parallel line look. And my last point.
Sir, cut at 5 or 3, sir. You mean, sir?
3 and 5.
It cuts at 3. The first one cuts at 3.
Yes, 4, sir.
Yes, you did say 4, sir.
You serious?
No man. That was an error though, Sidela.
Yeah, that was
So y equal to 5.
I think one of my brain cells just died a while ago, so
possibly.
So, all right. So then yeah. So when 2 lines meet at 90 degrees, class. When 2 lines meet at 90 degrees, all right. What's another name for 90 degrees?
A right angle.
Right angles, right angles, right. Anybody know the other name? Starts with P.
Perpendicular.
Right. When you're doing construction, You're familiar with this now? Perpendicular what? Bisector, not true?
Mm-hmm.
All right. So when two lines meet at right angles, all right, their product, right? So all right, what? Yeah, the products of their product of their gradient is equal to -1. What am I talking about? Basically, what am I trying to say?
One gradient.
All right, first of all, let us look at what perpendicular line looks like in real. So we have y
Negative 0.5 x
or negative
0.5
x
plus something.
plus 3. I'm gonna use 3. Let me use all right, class. So this was our original line, and this is our perpendicular line. It's perpendicular to what? The first one. So if you're to measure this angle here, it will be 90 degrees. All right. Now it is called a perpendicular bisector if I cut the line exactly in two, but I mean, it could go anywhere. Something. But if it's called a bisector when you cut it exactly in what? Into two parts. All right, so let me give you all right, so after this we're gonna go to a question, a possible question, and I think we're gonna get some screen time break. All right, so what's on? So the first gradient, M1, was 2. Agree, class? It was 2, right? And then no, the second gradient would have to be. All right, what did I say about when gradients are perpendicular? What did I say? I said when you multiply the two gradients, M1, M2, what you must get? You must get -1. So basically, if the first gradient was 2, all right, so 2 times another number should equal to what? -1. The only number that can go right
Sir,
there
is it a negative number, sir?
it would have to be a negative number, because a positive and negative be a negative, and then this other value would have to be a half. Not true, because it's 2 times a half, 1. So the other product, the other gradient would have been what? -1/2.
Okay, sir.
All right. Let me test the skills before I go. Before I hand over to Ms. Hilton. Suppose I say the gradient of the first line. Let us say for argument's sake, just for argument's sake, the first one wasn't 2. Suppose the gradient was 3, and I ask you, and they're perpendicular. I tell you they're perpendicular. So if they're perpendicular, it means that the product of the gradient must equal to -1. What would be the gradient of the other line if the first one is 3? Anybody?
1/3.
Thank you. You missed out one something though.
Negative
Negative. It would have to be a negative here. It would be -1/3. Let me test the scale. Suppose it was -5 was the first one. -5 was the first one. And I told you that 2 lines are perpendicular. What is the gradient of the second one? What number would this be? In the box.
Sir, positive 1/5.
Positive 1/5. Very good, because this is already negative, and true.
Yes.
You couldn't make the second one negative, because 2 negative will give you a what? A positive. All right. Okay, class. So,
Sir, can you give them a break, sir? And then at about 11:45 we
you
resume.
sure, Mr. Hilton, my fee said they might catch it, you know.
So you want to get
Yeah,
into
I think we should just give them the
Excuse me,
question.
sir.
Yes.
Okay.
I wasn't finished writing out this page, sir, that you were just
All right, so I guess we can break at 12, then, sir. So use time wise.
Why? I think I deleted it here. Sorry about that. Sorry about that. All right. So, Mr. Hilton,
Yes, sir.
take it away.
All right, so we are now going to apply all that we have learned to just now to a question. All right, so here we have a graph in front of us. It's already drawn for us. It says the diagram below represents the graph of a straight line which passes through the points P and the Q. And I know all of us were seeing the P and the Q, and you are allowed to zoom your screen so that you can see clearly. So there we have it. We have our P, we have our Q. Let's see what the first question is asking us for. State the coordinates of P and Q. That's 2 points. So 2 marks. So let us look for the P and look for the Q. Now, the word coordinates, anybody can tell me what they're asking us for? Sir said it earlier in his discussion. They want us to write the coordinates of P and the coordinates of Q. What do you think they're asking for?
Relation,
Numbers,
numbers,
all right.
The values of P and Q.
The values of P and Q, not exactly
Position of P and Q.
the position of P and Q. So what are we going to look for now? We're going to create a what now? Starts with O. Starts with O. Ordered pair. So we're going to have ordered pair, an ordered pair for P and an ordered pair for Q. So what is involved in an ordered pair? What values do we have in an ordered pair?
X and a Y value.
X and a Y value. So which one normally come first?
X.
The X value. Good. So let us now zoom in on P and write the X value and the corresponding Y value. So let's look for P. So there we have it. That's P. What is the X value for P and the corresponding Y value? Let me hear you. Ordered pair. We want to write the ordered pair.
P,
Ordered pair. Nice. So what would be the X?
negative
0.
2.
All right. So we hear 0, sir. Let us see. And what would be the Y?
3.
All right. So let's look at it carefully now. So if you zoom in on P, you realize that P is located on the Y-axis. So because it is exactly on the Y-axis, it means that there is no horizontal movement. The only movement that is taking place is vertical. So look, it is pointing to the 0, you know. Sir, look, it's pointing to the 0 on the x-axis, whether you believe it or not. So it is in line with the 0 on the x-axis, and then we move up to the 3 on the y-axis. You have to be careful because persons normally lose some marks right here. So you have to tighten up on your reading skills. So very good. Any questions on that before we move forward? So the coordinates for P are 0, 3. Those are the values. Q, let's move on to Q.
Hold on, Mr. Hilton. Quick question. Can someone tell me, if I were to put a point right here, sir, what will be the coordinates for that point there?
0 and
0.
5, sir.
0, 5.
Thank you very much.
Nice.
Very good. Very good. Very good.
Very good.
Awesome.
Very good. All right, good. Next, moving forward. So we get 1 mark already. So let's move on to Q. So now we are asked to write the coordinates of Q. Again, we're looking for an ordered pair, and in the ordered pair, we have X first and then Y next. Now, do you think there's an X value in this case? Is it still 0?
No, miss.
Yes,
What's
miss.
the X value?
Negative 2.
So if you look now on the x-axis, the point is located on the x-axis. So there is now an X value. It's negative 2. But when we look, we realize that the point is not moving up or down, like it's stationary. right? So what do we say now? What's the y value?
0.
0. 0.
Miss, I
Because,
don't quite understand, Miss.
all right, so you have to talk to me now, Sidela. What is the issue now with reading?
Miss, where the 0 is, Miss, the point that is 0, Miss, I must not there, Miss.
Repeat.
Where the point is at the 0 and above the -2.
Which one of the point is she referring to, sir? I'm not sure if I'm getting it.
On the x-axis, Miss.
This is Q.
Yes, Miss.
And the coordinates for Q, meaning the location of Q, is -2 for the X and 0 for the Y, because it's not moving up or down. Because, Sidela, for you to come up with a point, you must always have an X movement, horizontal movement, and a vertical movement. Sir, put a point in space for me. Put a point at 3, 2 or some or thereabout, and call it G or so. Nice. So let's look at G, Sidela. What if we had G? What would be the coordinates of G? So I don't like where you put it, you know. This one now go test understanding. Put it at 3, 2 or somewhere there. Yes. So Sidela, what if we have this point here? Tell me the coordinates of G, Sidela.
+1 and +3.
So which one are you putting first?
The x-axis +3.
And then?
The y-axis +1.
All right. So what you need to do then, Sidela, is to just focus now when the point, you see, when the point is located on either of the axes, Sidela, then it's a bit tricky.
Okay, Miss.
So you have to just pay attention to that. That is what you need to tighten up on. So you know how to write it, but you just need to pay attention to where it is located. Sir, do you have any follow-up on that before I?
All right. So look, one for everybody else. Would you agree with me that on the x-axis there are no y values? Would you say that is true?
Yes, sir.
Right. So if I were to write a coordinate or a point on the x-axis, all these values here would have to be 0. So the second would have to be 0, because on the x-axis we don't have what? Any y values. So for example, look at this one here. This one is what would be the coordinate for this one?
0, 4,
Oh,
sir.
no. Can't 0 come. Which number would you put first? 4, then 0.
Yes, sir.
Must x always come first, you know. Suppose it was.
So what come first, sir?
It's always x.
The +2 here, and then the 0 on the x-axis.
I'm not sure.
So what I'm saying, sir, always put in the coordinates for the y-axis first before the x, sir.
But you cannot
That's
do
why
that.
I'm making a mistake.
No.
Yes,
I think I understand what you're saying.
Okay.
Always put the x first, then the y. Yeah.
Yes, sir.
Try to figure out the x number first, then the y. If you try to put the y number first, then x, you might have some problem. All right.
So we're good now?
All right.
To answer
Yes,
that
please.
question, Sidela, any other question?
Yeah, and hold on, Mr. Hilton. Just one more point, that on the y-axis, we don't have any x values. So all these numbers are going to be 0. Your class? Yeah.
So
And another.
sorry, go ahead, sir.
Yeah, and another point too, that it is important that when they talk about coordinates, we talk about 2 numbers. All right? This is a popular question, multiple choice question. And you know what response A is? Response A was 3, -2 in the multiple choice. So what they do? They put on the 3 and they put on the -2 and say, yes, he answered it. Would this be correct, class? That'd be wrong, Andrew. That'd be wrong. All right.
So or maybe they may have -2, 3, 2.
-2, yeah, all kind of stuff.
All
right. So everybody following? Can I close this off?
So quick overview, once you're reading off your coordinates, you look for your x value first, then your y value, right? You will not always have an actual number. Sometimes you will have a zero, so you just have to be careful with that. All right, good. All right, moving forward. Everybody good? So everybody will get that 2 mark and we're good. Nice. So the next question is asking to determine the gradient of the line segment PQ. We're not going to use a formula, so let us see if we can use the diagram, use the technique that Sir taught us earlier to get this gradient. Anybody can remind me of how we go about it? What's the first step in getting the gradient? Anybody remember anything? First step in getting the gradient. So step 1, we are going to write down the idea of rise divided by run. So we're going to come up with that idea because we're not using the formula. So we're just using this technique, rise divided by run, that came from the tangent formula. Once we have this written, we are going to create a right angle triangle that is capable of giving us some square numbers without have to getting any half or thereabout, right? So we want whole numbers when we're counting. So let us create that right angle triangle, sir, anywhere on the line. Can have it at 1. We're in line with the 1 there, the 1 on the y-axis. So you're sleeping?
No, man. Where exactly?
Right there at the 1. So we're starting. So get in line with the straight line because you know that will form the hypotenuse. So draw the base, sir, from the straight line, and you can stop at the.
I was thinking.
Yeah, I just did the issue.
Okay.
All right. Nice. So there we have it. We have a nice right angle triangle. Remember, we said that we don't want to draw a triangle and have any half a piece or 1/3/4 piece or something. We want to make sure we have full squares.
I think what Mrs. was saying, don't draw a triangle like this, like like that. And
when you
look, because it's going to be very difficult to read off those values.
Yes.
So what you do, you try to draw off perfect. For example, you could actually do this. Oops. You could actually do this.
Yes.
So you get some nice whole number values. And also remember that you could actually do something like this. It doesn't matter how you draw a triangle, not true?
We just want to ensure that we cover the full squares.
Right. So in the case where it is not so perfect and nice like this, would be another issue where they want you to read between the small values. All right. So that's another issue.
All right, so let us revise now. So step 1, we're finding the gradient. We talk about gradient being, talking about the slope of the line. So I'm sure you already can predict what type of gradient you are going to get in terms of the sign, whether it's going to be positive or negative, because sir spoke about the bamboo stick and whether it is sloping to the right or to the left. So I know you already have an idea of what that is going to be. But anyways, let's do it in order. So step 1, we write down the little rise over run, because we're not using the actual formula, we're using this technique. Step 2, we try to get a nice triangle where we have some solid squares there in the area that we identify. Once we do that, then we count the rise, which would have been the vertical movement. So let's go. So we start at the bottom and we move up. So 0, 1, 2, 3. So the rise would be 3. Then we look at the run now. Again, 0, 1, 2. So we have 2 full squares right there. Nice. Now, once we identify the gradient, then we can now look where the line was sloping. Was it sloping to the right or to the left? So we can determine what sign our gradient is going to have. So I want to hear from you. Was it sloping to the right or to the left?
To the right, miss.
All right, so to the right, once it slopes to the right, then we know indeed we're going to have a positive gradient. So it's going to be positive 3 divided by 2. Nice. Beautiful. So we get 2 marks for that. Are there any questions? Talk to us. Are there any questions?
All right.
Yes, Natalia. Go ahead, Natalia.
Miss, I noticed that you didn't put the negative sign on the 2.
But what do you mean? You're looking at the numbers on the axis.
Yes, miss.
No, we're not looking at the numbers, Natalia. We're counting the spaces. Because if you do that, you might put yourself in problem here. Okay,
Yes,
Natalia? Yes, so we're just counting the movement, and then when we're finished counting the movement, we make a decision based on how the line is sloping.
Right. I was going to make that point. All right. So, for example,
so draw the line in a different direction.
Suppose I do something like this. All right. So you're not going to look at these numbers here. You're not going to look at those numbers. You're just going to count from the square units. So it says 0, 1, 2, 3. So you don't say 3, then 4, then 5. You don't. It's going to mix up. It's going to mix up.
Very good question, Natalia.
Yeah, it's a good thing to use because
Yeah.
Yeah, and also to mention that.
Sure, we must always start counting by 0, then 1, 2, 3,
yes,
or 4.
Yes. That's what we call. It's just like when you're born, When you're born, you don't say you're 1 year old, hello? You have to wait for what?
0, then 1.
Right, you have to wait for 1 year for this boy. You're 1 year old.
All right, nice. So the gradient is 3 over 2, and we agree that it is a positive gradient based on where the line is sloping. All right, very good. I think we're doing very well. Part 2, determine the equation of the line segment PQ. I think we're doing very well, sir. Let us get back to, you're doing it here? All right, so what is the general format for a straight line equation? Let me hear it. Chorus.
Y equal mx plus C.
All right, remember now, we want to hear from others too, very good. So this is the general format, and we spoke about the y being the independent variable, the x being the y being the dependent, the x being the independent, m being the gradient, and c is the point at which the value where you have that straight line passing through the y-axis. All right, so let's see if we can start plugging our values in and get our 2 mark. So we normally leave the y without putting anything there. So sir, we're writing our equation now. So we just found the gradient. What was it? Let me see who's paying attention. All right, so 3 over 2, that's the gradient. So we put it exactly where the m is. What do we put beside this 3 over 2 now? Let me see who's paying attention.
The x.
Put back the x, very good. Now we need to put the value now for c in. Somebody remind me of what c is again. Give me a definition of c.
The cross section of y, miss.
The cross section, all right. Your eye level, Samuel. You can break it down. Break it down.
Where the line crosses y, the y-axis.
All right, very good. So let us see if we can locate that. What is it now? Look at it. There you go. So there is the line. There is the y-axis. Where does it cross the y-axis? Where does it touch the y-axis? Where does it intersect with the y-axis? What you say?
3, miss.
All right, nice, Lola. So it intersects the y-axis at the point 3. So we just go put on the value right there. So is it a positive 3?
Yes, miss.
We'll just put on the positive 3 and you get your 2 marks right away. That's your equation. If you have a question, ask it now. So the general format for the equation is y equal mx plus c. When the examiner asks you to come up with the equation, indirectly they're asking you to input your gradient as well as the value for c. Go ahead, Natalia.
Could we use the 1.5 instead of the 3 over 2?
What do you think? You tell me. Tell me, Natalia. Yes, because they both have the same meaning. So 3 over 2, 1.5, same meaning, same value. So yes. All right, moving on. Any other question? All right, moving forward. Nice. So we get how much mark that we get already? We get 6 marks already in CXC, but we are going good. All right, part C. The point
So this
negative.
question is that just the answer there? There's no other working out?
No other working out for this particular type of question.
Okay.
If we are using the graph, then yes, we just do the rise over run, get our gradient, then we look to see where the line cuts the y-axis to get our c, and we just put them in their respective position. We don't touch the y, we don't touch the x in this case.
Good
Right?
question. Good question. Let me just make a point here that if you get a question where they give you the graph and the line, this is how you do it. It's pretty simple. But we have instances where no graph is given. When no graph is given, we're going to show you how to get the equation. There's another technique. All right?
Yes. And sir, if they feel comfortable using the other technique, in this first case, it can be used as well.
Yes, yes.
Because if you realize the first part of the question, I'd ask them for the point. So the other technique that we're going to show can be used with a graph, without a graph, you decide. All right, so nice. Part C. The point -8, comma t lies on the line segment PQ. Determine the value of t. Quickly, how would I go about doing that? A question like that. Sir did this, so I'm just going to quickly get into it. So we know that once we have a point, then we start looking for x and y. We can name the values. So in this point, -8t, we know that x is the first number that we see, which would have been -8. So x is equal to -8. And y is equal to t. So in other words, you are asked to find out what y would be or what y is going to be when x is -8. So the concept that we had started with from the beginning, where we were completing that table, is what we're going to do, inputting values basically. Now, once we are going to input values, we must have a rule, we must have a relation, we must have a function, we must have an equation to input values in. And that is why you were asked previously to come up with the equation, because of course it is going to assist you in answering your further questions. So now that we know what x is, we can input this value in the equation in order to find out what y is, which in essence is t. So we're going to input some values now in the equation. All right, so we write back the equation, sir, so you can copy and paste. All right, so we know that x is -8, so we're going to substitute, we're going to plug in that value wherever we see the x. So we'll put back the y. Sorry, I choose to put t when I'm finished. So we put back the y and we work it out, and then later on we tell them that, okay, t is equal to so and so. So we put back the 3/2. And what are we going to times it by now? Let me hear you.
-8.
All right, nice. Then we'll put back our 3. Now we are going to treat this as a regular multiplication or fraction that we would have been used to. So of course we can reduce, we can break down. So where did you get that k from?
From the alphabet.
Okay. So when we break down, we say 2 into -8 goes -4. That's true. So we have,
Yes, miss.
nice. So we have a -4 remaining there. So we have 3 now times -4. Give us what?
-12.
-12. Everybody understand where we get that -4 from? We use the 2 to break down the 8. All right. So -12 now plus 3.
-9.
Very good. So the value of t is -9. So let's go again. So when we look at this question, we realize that they were asking us to calculate the value of y when x is -8, but they didn't want to make it so straightforward, so they tried to twist it around and put a different letter there. But we know, -9, sir, we know that once we have an ordered pair, then we know that it is made up of an x value and a y value. So we know that in essence, the t there would have been a y value. So we say, okay, we not can use the formula what we have and plug in. It's not no big deal. So we just use what we have to get what we want. So we know that once we have an equation, if we know the value of the unknowns there, then we can use it to solve. So we know the value of x. So we use the value of x, plug it in, and get the value for y. Very good. So we have 8 marks already. We're doing very well. We're doing very well. So we're moving on now to the last question.
Just one more point, Mr. Sultan. So the completed thing would be -8, -9. All right?
All right. Nice.
So this will be the point. And sometimes they can ask you to even plot it.
Yes.
Yeah.
All right, very good. So let's see what the final question is asking us to do. So it says, the line segment AB is perpendicular to PQ and passes through the point 62. Let's read it again. The line segment AB is perpendicular to PQ and passes through the point 62. Determine the equation of AB in the form y equal mx plus c. We have PQ. We don't have AB. So we are now going to create the equation for AB based on the knowledge that we developed earlier. What do we know about lines that are perpendicular again? You have to look for the keywords now, we know. What do we know about lines that are perpendicular? Because guess what? This line is not actually on the paper, you know. So you have to open up your imagination now. So what do we know about lines that are perpendicular to each other?
They have the same gradient.
Think about it. That was the last thing that sir did. They don't have the same gradient. Think about it.
Miss, their gradient.
Temporarily? Oh, no.
What did you say,
No,
Lola?
right, that's mistake.
90 degrees.
They are 90 degrees. They meet at a 90-degree angle, yes. But what do we know about their gradient? Sir, go back to the page where you
-1.
always -1. The product. So let me give you something and see if you're gonna remember this. With parallel, the gradient them go be exactly the same number. But with perpendicular, one of the gradient will be the negative reciprocal of the other. What I mean by that? If one of the gradients is 3/2, then the other gradient you are gonna have to reciprocate that, meaning flip it, turn it upside down and negate it. So you may tell me that the product is -1, but do you really understand what it means that the product, you can't just write down that the product is -1, you know, because you're gonna have to know the gradient of the corresponding line that is perpendicular to PQ. So we have PQ, and the gradient of PQ is 3/2. That are the line we 6 give it. This is one up on the page. The gradient is 3/2. So if we have a line that is perpendicular, so it's going to give us a demonstration. Just draw a random line, so I could call it AB. Just draw something that is perpendicular to that, sir, and we're calling it AB. I just want to have the line so I can improve on my explanation. Good. So this is AB now, class. So the examiner wants us to come up with the equation of the line AB. Now, we know that the gradient for PQ is 3 divided by 2. In order for us to write the equation of AB, we must know the gradient and we must know the C. So what would be the gradient of AB if the gradient of PQ is 3/2? We're talking about the new line now. What would be the gradient of the new line? The AB, what would be the gradient? Reciprocal, negative reciprocal, negative
2/3.
All right. Negative reciprocal. Nice. Very good. So let me slow down and read the question again. The examiner wants me to come up with the equation of the new line. The new line is AB. I must come up with the equation of AB. In general, once you're asked to create the equation of a line, you must ensure that the gradient is visible and the value for C is visible. So the reason why I'm asking you what the gradient would be is because we need the gradient. And then I know that there is a connection between lines that are perpendicular. Referring to the gradient now. So we said the product of both gradients should always give us -1 regardless of what the line is. So in this case, the gradient of the old line was 3/2. So the gradient of the new line, AB, which is perpendicular, is -2/3. Are there any questions before I move forward?
Miss, are we supposed to draw a line on the graph, Miss?
No, we're just
Okay.
doing it for explanation purposes. Just to show you that AB is actually a new line that they are asking about now. But they told us that there is a relationship between AB and the old one that is PQ.
Ms. Hilton, if you allow me,
Yes, sir.
basically, what happened in the question, right? All right. The question says,
We're not answering it yet, you know, sir.
I
But
know,
if
I
you're
know.
adding to it before,
Mhm.
we're not
So
finished.
I know, man. So it says a
Okay.
line. There's another line segment. So initially, we have PQ, all
Yes.
right, and there's another line segment which is not there. So they never draw the line. So is it the way in which we got the equation of this line here? We got equation from that line because the line was drawn. But no, they're asking us to find the equation of one new line that is not on the board,
Not on it.
on the paper. So no, we have to use another technique in which we're talking about. All right? And the new technique of finding the equation for the line, two things. We need a gradient and we need a point. Now, do we have a point for the new line? What is a point for the new line? Isn't it 6,2?
6,2.
Right. So now we need what? A gradient. Now to get the other gradient class, as Mr. Hilton was saying, we have to use the concept that when two lines are perpendicular, because they did say that lines are what? Perpendicular. That the product
of the gradients.
Right. What am I gonna say? Right. The product of the gradients M1 and M2 gives you -1. So what we really need is we need a gradient of the other line. All right. So once we get the gradient and we have a point, we can what? Construct our equation of the line, which is more technical than this. All right. So it's pretty simple. Let me tell you. It's anytime you get a straight line and the to find find the equation, it's pretty simple. But if they're not giving you a line, we're not going to lie to you, it's kind of heavy. Not really heavy, but it's more difficult than this is. Because I think I remember Sidela was saying, sir, how does that? Because basically we just put in the M and the C and we're done. All right? But it takes more effort when the line is not there. So that's what we're going through. So let me run it again. Summary. Number one, when the line is there, we need to find a gradient and a point. Do we have a point? Yes. All right? If you're going to ask us, sir, suppose they give you 1 point, they have to give you 1 point.
But sir, even if the line is there, we still need the gradient.
Right.
But because it will affect us with the C.
The C, right.
Because we don't have the line, so we're not gonna know where it cut the y-axis. So that will give us some problem to find that C.
Right.
But imagination, now we're opening up our imagination. It's not there, so we will have to calculate the C because it's not there.
Right. So this one is more technical.
Yes. So, sir, go back to the page where you're doing the calculation. So, now that we know the gradient, so write the equation now for me, sir. Y equal mx plus c. So, we're taking it from the beginning now. So, the examiner said them want an equation for this AB. Y equal mx plus c. So, they want us to put the equation in the form y equal mx plus c. Once you're asked to write an equation under any circumstances, you must ensure that you include the gradient and the value for C. Sir, highlight those for me, please. So once you're asked to highlight the C and the M, red or something. So once you're asked to write an equation, you must ensure that the value for M and the value for C is taken care of. It is visible. Now, for this particular line, we know M based on our previous knowledge. m is negative 2/3. You cannot use back the same gradient. At two different lines we are talking about, they are not parallel, so you cannot use back the 3/2. So in this case, for the line AB, the gradient is negative 2/3.
Please ask questions if you're not following. Negative, is it 2/3?
Yes, sir. All right, good. So I'm going to repeat. Whenever you're asked to come up with an equation, you must have your value for your gradient represented and the value for your y-intercept, right? So we know the gradient. In this case, it is negative 2/3. Now, what is left for us to calculate? Or what is left for us to find out? I said it just a while ago, you know, if you were listening.
C, miss.
All right, so we need C. We need to find out C. We need to know where the line cut the y-axis. Can we look at the graph that CXC gave us and tell?
No, miss.
No, why not?
Because they give it 2 different points.
They give you 2 different lines. This is a line here, not the on graph, right? So we can look and tell if this a particular one here. Because see question here, you know, did it, right? So what we're gonna do now, we're gonna have to calculate the value for C. But guess what? This technique that we're gonna use will not be foreign to you, because all we're gonna do is to plug in some values to get our unknown. So let us imagine the equation y equal mx plus c. We were given a point 6,2. They did not just give us that point to put down. They gave us that point to use. In that point, we have a x and we have a y. The x is 6 and the y is 2. So if we look at the equation, the general form, if we plug in the y, plug in the m, plug in the x, then a C alone go missing. Let me go again, because it might be a little bit heavy, so let me take my time. We are going to use the m that we have. We're going to use the x value from the point that they give us. We're going to use the y value from the point that they give us, plug in those, and the only thing that we don't know is C. X is 6. How did I know that? X compared to the other here, not true?
Yes, yes.
All right. Y is 2. How me know that?
Miss, because when you label the values, y is in the the y. Okay.
Yes, Devante, Spanish. All right, sir. So you can start plugging in the values now. So wherever we see y, we're going to put 2. Our gradient is negative 2/3. X is 6, so we're putting times 6 right there. Do we plug in a value for C?
No, miss.
All right, so C is what we're trying to find. So just with the like what we did earlier when we were calculating T is a similar technique we're using right here. So we know our X, we know our Y, we know M. So the only thing that was missing is C. So what we're doing, we're using what we have to get what we want. So it's like we're solving an equation We only have one unknown at the moment, and it is C, so we're calculating C. So we're reducing that multiplication right there. We can use the 3 to cancel the 6 or to divide the 6. So 3 into 3, 1. 3 into 6, 2. I'm not sure sir is sleeping, but I'll give him a little bit of time.
No, just it's kind of difficult to type that. I'm just gonna write the answer.
All right, so if we say 3 into 3, 1, 3 into 6, 2, then we will have negative 2 times 2. All right, and we will put back our...
Question is,
Yes.
how did we get the 2?
How did we get the 2?
Mr. Cancel, miss, like 3 into 6 was...
Yes, yes. I was expecting sir to show you, but you say it a little bit hard to write it. Yes, so we use that. Yes, Sidela, that's what we did. So we cancel that. All right, so now we have negative 2 times 2 give us negative 4. Plus the C. So we're solving this equation now. What do you recommend?
Mr. Can get rid of it.
Get rid of it?
4, negative 4, miss.
By doing what?
Adding 4.
Very
to
good.
both sides.
Very good. Very good. Very good. Very good. Very good. So we add 4 to both sides. So we end up with 2 plus 4. So C in this case is what?
6.
6. So let us see now. Have we answered the question? Did we write the equation? Did we write the equation? No.
Yes.
So let us write the equation. No, we don't write the equation.
Okay.
Remember, we say when we write the equation, 2 things must be visible, the M and the C. But because we never have the C, we calculate it. So now we are going to put everything together now and solve the puzzle. So let's write the equation now, sir, and get the 3 marks. So therefore, the equation of the line is y equal negative 2 over 3x So I'm going to summarize this in a sentence or less. So what we did a while ago was to create the equation of a perpendicular line, perpendicular to the one given. In essence, once you're asked to create or to write an equation, when you're finished, you must ensure that the value of the gradient is visible as well as the value of the C, which is the y-intercept. Sometimes you may be able to look and tell what the value of C is, while in other cases, you will have to calculate it. So that's what we did. Sir, your final word.
I'm hungry. Sorry.
Me too.
I guess let me tell you. Finding the equation of a straight line when the graph is not given is difficult. As you can see, it is a lot. Comparison to this, not your class. I mean, that was pretty straightforward. However, the level of difficulty turn up when you're not given the line and you're asked to build the equation from scratch. All right. So in summary, they would have asked us to find the equation of the line that is perpendicular to the line segment PQ, and that name of that line segment is called AB, and that line segment passes to the point 62. All right, and in summary also, we use the fact that when two lines are perpendicular, the product of the gradient is equal to -1, and then we use the negative reciprocal concept to find the other gradient. Because you notice we never draw a line and say rise over run to find the other one, not true? Right, you have to use the negative reciprocal to find the -2/3, all right, for the other gradient. And then once we have the gradient, you notice how I put my answers? I write down what we know, not true? Look, see? That's how you should answer your questions. Write down what you know and what you want. All right? Right, like when you go KFC, that's how you go. Right, you know what you have to spend and you know what you want. Right, so you write down what you know.
And you look
So
at Ford and see what the prices are.
exactly. So you write down what you know. You know, say boy, if you buy this, whatever. So we know so the product of the gradient is equal to -1. We know that the 0.62 lies on the other line segment that's perpendicular to PQ. And we know that x is 6, y is equal to 2. And we know that the gradient is -2/3. All right. And what we need to find is now what? Is C. All right. And as Mr. Hilton said, we use this formula here. We plug in the gradient. All right. And we plug in the x and the y. And the only thing we left back is what? C. And once we find C, plug it back into the thing. Because some students know when they find the C, they think that is it.
Yes.
Yeah. But that's not it. You actually won't get the full marks. Once you find the C, you have to plug in it back in the thing.
Because they make sure to let us write equation in the form. Like they literally, they spell it out and tell you. So you have to make sure when you finish, or did I answer the question? Right? You ask yourself that.
Right.
Yeah. So what if the question had said parallel? Would we need what would be different in this question?
All right. Good question. No, in let me go for my notes.
All right.
In my little notes now, what did I say? When two lines are parallel, they have the what?
Same gradient.
Same gradient. Is that something about negative reciprocal? You don't have to do that. So all you have to do is use what the original what? Gradient.
So M1 would be 3/2, M2 would be 3/2.
3/2. Right. So it will be a little bit easier, you know. So you don't have to go through the M1, M2. But you still have to use the X. You still have to use the 6 and the 2, and you still have to find C. It's just that when the lines are parallel, you use the same gradient. If they're not parallel, they are perpendicular. All right. So the Hilton is 12:25. So
we can give them 15 minutes to grab a bite.
All right. Okay. So it's 12:25. So we return at 12.
Question, sir. Can you let me write up the part?
12:40.
12:40. Yeah, man. We will leave this up.
No, sir. The point, sir.
You mean the notes?
Yes, sir. Yes, those, sir.
Oh, let me tell you. I will send this. Well, this thing is recorded, you know. So,
but I'm almost finished, sir. That's
all right, no problem. And for those of you, I will have this uploaded on my channel later this evening, so you can actually look at it. It's gonna be pretty long though. Pretty long. So we'll return at 12:40. Mr. Hilton. Mr. Hilton gone. All right, so we'll return at 12:40, class. Bye-bye.
Okay, sir.
Yes, sir, 12:40.
So if you leave and come back?
Say that again, please.
We must leave and come back.
No, you don't have to. You don't have to come off. You can just stay. You can just mute your mic, and it's 15 minutes run off in easy. But if you're using data, and you can exit. Alright.
Finisher.
Testing. 1, 2, 3. Testing.
Mic check. Testing for quality.
Yeah. No, my thing is having some problem. So.
Okay. All right. So I'm assuming we are rejuvenated. We're ready. We're ready. So we are going to do another question involving straight line. This one may require the use of formulae. I will provide them, or we will provide them as we go along. So just pay attention keenly to the different concept that is covered in the question and the formula that we're going to use to answer that particular concept. Grab your paper, grab your pens, your pencil, and ensure that you write these down.
And just to mention that these formulas are not given in the exam, right?
No.
Unfortunately. And also to remember that you notice that this is a graph question and there's no graph given.
Yes.
Right.
All right. And you're not required to draw the graph either, because the question did not tell you to do that, right? So what we're going to do, we're going to, as I said before, utilize some formulas and we are going to get the work done. So the question reads, the line L passes through the points S, 6, 6, and T, 0, -2. Determine 1, the gradient of the line L. So there is a formula indeed that we use to calculate gradient of lines. And sir is going to write that formula right now. Now, I will allow the formula to be written before I say anything further. But if you look keenly though at the question, you realize that you were given 2 points. So that will provide you with a little bit more clarity on the subscripts that will be used shortly. So I'm waiting on the formula, then I proceed. So the formula reads y2 minus y1 all divided by, who can tell me what they think is going to be at the denominator? Let me see. Who can tell me? We're dealing with points, and once we have points, nice. So once we have points, then naturally that's where the x and the y comes about. But you may be wondering, Miss, why the 2 and the 1? Can somebody tell me why you think we have y2 and y1, x2 and x1? Anybody think they have any idea why those are connected? Anybody? So we have 2 points. We are given 2 points, S and T. So naturally, in an ordered pair, we have X and Y. But because we have 2 points working with now, we're going to name one of those our ones and the other our twos. So you can decide which one you name your one and your twos, but we're just going to follow the order based on what we have. So the point S, we're going to call the 6 our X1, and we're going to call the other 6, which is the Y value, our Y1. So we're labeling our points. Then we're going to take the point T, and we are going to be doing a similar labeling. But I'm sure we would have used up the ones already. So we're moving to the other number, which is 2. So again, we're taking the X value, which is 0, and that will become our x2. Can somebody tell me what is y2?
2, miss.
I'm not seeing any 2.
-2.
Okay. All right. So x2 in this case is 0 and y2 is -2. Are there any questions before we proceed? Any questions? Any queries? All right. So we have successfully labeled our points. And the labeling was pretty straightforward. I mean, there was nothing technical about it. All we did was to take the points and label. That's all we did.
So then there's one little point. Let me just try to highlight.
Mm-hmm.
All right. So one of the common errors that students would make is to call this x1,
Mm-hmm.
and for some strange reason they call this other one x2. Right. So that's wrong here. That's a common error.
Yes.
So remember that this is an x value, but because we have 2 points, we say x1 and x2.
X1, X2, correct.
And we have 2 y values, so we call it y1 and y2.
Correct.
All right. So remember to look out for the common error. Some people said this, they just call this x and y. That's an error.
Nice. So naturally, and we spoke about it this morning, sir, naturally in an ordered pair, you must have a y and you must have a x. You will never have 2 x's in an ordered pair, and you will never have 2 y's in an ordered pair. And we did say the reason why we number them with the 1 and the 2, because we have more than 1 point. That's the only reason. And I think that's pretty straightforward. All right. So now that we have labeled, what do you think is the next step? Now that we have identified our y1 and our y2, our x2 and our x1, what do you think is the next step? I want to hear from Keandre. What do you think is the next step? So Keandre, plug in the device and gone. I want to hear from Samuel. What's the next step?
I won't just forward them, but so me look, Miss say I find a gradient. That's the other miss.
Mm-hmm.
So you need to find y2 and y1.
Mm-hmm. I think we have done that. If you look carefully, we have labeled. So you said I should pick up y2 now. So what is y2, sir? Based on what we label, what is y2?
All right, let me see. y1 equals -2.
All right, nice. So we put -2. Very good. We'll put back our minus from the formula. Very good. What is y1 randomly? Somebody speak to me. Just one.
6 and t.
Very good. 6. All right. Nice. So let's move to the denominator now. What's x2? Talk to me. Chorus. Pay attention. x2.
0.
0. Nice. Put the minus. Very good. What's x1?
6.
Very good. Nice. Positive 6. Very good. So let us simplify now using our arithmetic skill.
Question, miss. Why didn't you put the t and the 0 in bracket with the -2, miss?
I am
for y1.
Repeat.
Miss, why didn't you put the 6 and the t and the 0 and the -2 in bracket?
I don't know if I understand the question. However, we have yeah, maybe
Stella, you're not required to do that, because the S and the T are just labels of the points. All right. What we are interested is just the values that are inside. So S and T just represent the name of the point. All right. What we're interested in is to replace the y2, the y1, x2 with the values that are inside the S and the T's. All right.
Okay, sir.
Yeah.
You're good now, Stella?
Yes, miss.
All right, very good.
Quick question, class. What if x1 was not 6? What if x1 was minus 6? What's going to happen?
Very good question.
Turning a plus sign.
Thank you, sir. Right. So you'll have two negatives there, not true?
Mm-hmm.
Right. And to remember that this negative here is from the formula.
Mm-hmm.
All right. So the formula itself is a negative. So in this case, we have 0, subtract. The subtraction sign is from the formula. But if 6 itself is negative, you'd have 0 subtract negative 6.
An additional, very good.
And that would give you a positive. Very good. Very good.
All right, so let's finish up. So Stella is good, everybody else is good. So let's finish up. So
Yes, miss.
we have -2 minus 6. So naturally, we can predict that to be what?
8, miss. -8.
-8. All right. And then we have 0 minus 6. What do we have right there?
-6.
All right, very good. So now we have a negative number at our numerator and a negative number at our denominator as well. So what we know for sure is that we will end up with a positive fraction. So what you can do now is to simplify that 8 and 6 if you observe where it can be simplified. So what do you say? Do you say it can be simplified? Can we simplify 8 and 6? Can we break it down? Can we reduce it?
Yes.
What do we use to reduce it?
2,
2. So 2 into 8 goes
4.
all right, and the same 2 into 6 goes
3 times.
all right. So our gradient is 4 divided by 3, and you get your 2 marks for it right there. So this is you finding the gradient now using the formula because we don't have any graph, so we cannot do the whole counting off with the rise over run. So we have to utilize the formula. Everybody good?
Yes,
All
miss.
right. Moving right along, sir. Part 2. Determine the equation of the line. I want somebody to tell me. You don't have to tell me much, you know. Remind me of what we said earlier. Once you're asked to find the equation of the line, then you must write it in what format?
The general formula is
General format, which is?
y equal mx plus c.
All right. And when you write it in the general format, what are you expected to include?
The value for m and c.
All right.
Ready?
All right.
Not too bad.
So, sir,
Yes.
you're sleeping?
Oh, sorry.
So why?
Can you hear me?
Yes.
Okay, yeah.
So y equal, so sir, we are way ahead of you. So we did some recap just now, and we say that once the examiner asks us to write the equation of the line, then we must put it in the format y equal mx plus c. Now, once we identify the format, then we also should bear in mind that once you are writing up your equation, you must include the value for the gradient and you must include the value for C. So let me ask a question. Do you know any of those two? Do you know the gradient? Do you know C?
Yes, miss, we know the gradient.
You know the gradient? What's the gradient?
4/3.
All right, sir. So write that down for me, please. So we know the gradient. So we're writing down the gradient. So m equal 4 divided by 3. Let me ask another question. Do we know C?
No, miss.
Is it possible to calculate C?
Yes, miss.
When we calculate C, what format do we use? What do we do? Tell me it in a simple way. When we calculate in C, what do we do?
Miss, transpose.
So once you calculate in C, anybody remember? We did it not too long ago. Once we calculate in C, we use the same equation, the same y equal mx plus c. So naturally, we have m. There is a value for y. There is a value for x. So the only thing that we would need is c. Now, where is that y and x? Let me ask a general question. Where is y and x? Do we know y and x? Where are they? Think about the question. If you read what sir is writing, then you can answer.
Yes. Yes, miss.
Where is y and x?
Miss. Y is -6.
Is x 4, miss, and y 3? No, x 3 and y 4.
All right. So we are, go up to the top of the question, sir. So in this question, we were given 2 points. The examiner did not specify which one we should use, so we can choose any one of them. Because in order for us to do the calculation to find C, we need a x value and a y value. So we are going to choose to use either the point S or the point T. So I am going to select T. So I am going to use x as 0 and y as -2. So we're choosing a point, and I choose to use t, which is 0, -2. So x is 0 and y is -2. Why am I doing all of this? Let me repeat. I need to calculate the value of c in order to write my equation. I am using a straightforward method to calculate C. And that method is to use the same general format, plug in every other letter except C. So I'm going to plug in a value for letter Y. I am going to plug in a value for letter M. I am going to plug in a value for letter X. But the only thing that I'm not going to plug in is letter C, because that is what I want. How am I going to get letter M? I found it just now. How am I going to get letter X? I can use any one of the points given. I choose to use T. So my letter X, the value for that would be 0. And the value for my letter Y would be -2. Now that I know those values, except the C, I am going to plug them in. I am going to substitute them. I am going to replace the letters with the corresponding numbers. So Y is -2, me I go plug in that. M is 4/3, me I go plug in that. X is 0, me I go plug in that too. C is, I don't know it, so me I go put back C. All right, so me I go simplify now. I am going to do the multiplication part, but guess what? I love this question. What do you think is going to happen to all of that in the bracket? 4/3 times 0. What is going to happen?
Become 0.
It's going to become 0. It's gonna become 0 because anything that we multiply the 0 by will give us 0 for the result. So we have negative 2 equal 0 plus c. Now we know that if we carry over that 0, it won't change anything. Because naturally 0 plus c is c, because 0 does not have a value. So it won't change anything that we have. So c is equal to negative 2. Is the question finished?
No, miss.
No.
Miss Hilton,
Yes, sir.
quick thing. What if you didn't choose T? What if Miss Hilton had chosen S, which is 6, 6? Somebody tell me what to write in this part here. So it's 6, 6. What would you write for the y equals mx plus c?
Sir, copy that and put it to the right and plug them in.
6 equal.
Hold on, Mr. Mr. Are you saying something?
Yeah, you're good. You're good.
All right. 6.
Equal 4 divided by 3 times 6 plus c.
Awesome. Very good. And then do you realize that the 3 into 3 goes 1? 3 into 6 goes 2. So 2 fours is equal to what? 8. So you'll have 6 equal 8 plus c. And if you look at it, you still get back the c equals what? Negative 2. All right? So it doesn't matter which point you choose.
Love that, sir.
All right? You still get back the same answer.
Nice. But you see, sir, I just want them to ask the questions, because you see, if they really grasp this concept, then they're good to go in terms of calculating their C and stuff like that. So if something is not clear, it's best to ask no. Because we're not perfect, and we know there may be some hindrance. So if you have a question, just ask it. All right, so remember now, the question never ask if you find C, CXC, now go tell you find C. This is something where you have to know within yourself that in order for you to write the equation, you must include the value for the gradient and the value for C. And if you don't have a graph looking at, then this value for C will not drop out of sky. You will have to calculate it. Right? So this little technique that we're using now is to help us to find what that value for C is. And if we take some random points and plot this, draw this line, we will realize that it will pass through negative 2 without a doubt on the y-axis, the straight line I'm referring to. So now that we know C, let's write the equation. So therefore, the equation is y equal, what's the value for m?
4 divided by 3.
4 divided by 3. Then we put back the variable x. Good. And then we put the value for C, which is?
Negative 2.
Brilliant, brilliant.
But you realize that a positive and a negative will give you a negative. So you can just write negative 2. Even though it says mx plus c, and if c is negative, positive, negative, be a negative. All right. Silton, are you there? All right. All right. So I'm not sure what's happening. I will just continue. You guys hear me, right?
Yes, sir.
Yes, sir.
All right. Okay. So I don't know what happened to this. All right. I will just continue. So this would have been the answer for part 2. All right. So this represents equation for line. Let's look at part 3.
All right. I'm sorry about that, sir.
Oh,
I am
okay.
live and direct.
Yeah, man,
So
no problem.
part 3. So we got that 2 mark just now. So part 3 is asking us for the midpoint of the line L. So they want us to tell them if we should draw that line, what point would we have in the middle of that line, basically, right? So there's a nice little formula that is very easy for you to remember to calculate the midpoint of any straight line. And sir is writing that formula right now. So of course we know midpoint speaks about middle. So what we're gonna do, or what this formula does, is to group up the coordinates, right? And middle them, basically. Yeah, I hope that makes sense. Yes. So we take the x coordinates and we add them together and we divide by 2, find the middle. Then we take the y coordinates, we add them together just the same, and we find half of that. But because it is a point, you will realize that you will end up with a x coordinate and a y coordinate in your answer because it is a point, midpoint. We're dealing with points. And once we have a point, then we have an x value and a y value together. So naturally, in the working out process, you will group your, sir, I'm assuming you're sleeping, we're grouping the x's and the y's.
Oh.
Yes, you're testing us, right, sir?
Oh, that one was just...
We're not hearing you, sir.
You're not hearing me? Are you guys hearing me?
We're not hearing you.
Yes, sir. I hear you.
Oh, I'm hearing you, sir. I think my device was...
Okay.
So, sir,
All right.
you were hearing me all along?
Yeah, man, I was hearing you the whole time when I said not hearing you, but I thought that
yes,
I thought you guys were not hearing me.
I'm hearing you now. I think I solved the problem. All right, so we're grouping the x's, sir. So we have x1 and x2.
Hold on. Sorry. So that's...
Yeah, you're sleeping. Or you're testing us? Which one?
What?
All right. So if we go back to the top, because it's the same question, all these parts are connected to the same question. If we go back to the top, then you will identify, or you already know your x values, you already know your y values, right? So what we do now is to just take our x values, which are 6 and 0. So x1 is 6, y1 is 0. Nice. So we're grouping now. But with the gradient, we were subtracting. With this one, we are adding and dividing by 2. So that's the difference. So we're not subtracting now. We're adding and dividing by 2 in each case. So the x values are 6 and 0. So that's 6 plus 0. And the y values are 6 and negative 2. All right, beautiful. So once we are finished plugging in, we know that the next step is to simplify. And about mathematics, I mean, oh my God. So 6 plus 0 is 6, and 6 divided by 2. Everybody should be able to tell me that answer quickly. 6 divided by 2.
3.
All right. And then we have 6 plus negative 2, which is, somebody tell me.
Positive 4.
Positive 4. And positive 4 divided by 2 is
2.
2. Nice. So writing them as we go. Very good. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So our midpoint is 3, 2. X being 3, Y being 2. So there's a final part to this question. Determine the length of the line segment TS. But before I get to that, let us recap. So I want you to tell me the formula to calculate the gradient of a straight line given 2 points. It's on the board. I just wanted to say it. What's the gradient of the formula to calculate the gradient of a line given 2 points?
Y1 and y2 minus y1 divided by x2 minus x1.
All right, very good. If they ask you to write the equation of a straight line in the form y equal mx plus c, what should you ensure?
Miss must ensure say. Miss we say na equation.
If they ask you to write the equation of a straight line in the form y equal mx plus c, what should you ensure?
You
Say
should
have
ensure
M and C.
All right, and very good. And once you know those, you plug them in and you have your equation right away. If you're asked to calculate the midpoint,
Hold on, Mr. Hilton.
yes, go ahead.
Did she say we need to have M and C, or we need to have M and find C?
Well, I think I understand what she's referring to in terms of we must ensure that we include M and the C.
C. All right. Let me just expand on this a little bit.
No problem.
You see, anytime you want to find the equation of a straight line and there's no graph given, like this nice question we did a while ago up here, sir. Remember the first question? The graph was given a true, and we were asked to determine the equation of the line segment. I want to just plug in the M and the C. If no graph is given, all right, number one, we need to ensure that, one, we have a gradient and we have a point. In other words, the only way we can find the equation of a straight line when no graph is given is that, one, we need to have a gradient and we need to have a point. When you get the gradient and the point, you plug in those values in the form y equals mx plus c. Then you find c. Then when you find c, you put back c and m in the form of y equals mx plus c.
Sir, now that we have shown them the gradient formula, do you think you want us to use it to show them how to get the equation of the line and see which one they prefer? You want us to try it?
You mean the first question?
Now that we have exposed them to the gradient formula, you want us to use it to show them how to get the equation of a line right away without have to be worrying about what to plug in and stuff like that?
Oh, all right.
Do you want us to do that? So
You
then
mean
you want us to show you that and see which one you prefer?
You mean the other method?
Yes, it will be the other method to get the equation of the line.
All right. Okay, class. So basically what me and Ms. Hilton we're saying to you that there's another way of getting the equation of the line.
Gradient
right.
formula.
Yeah. Do you want us to let me tell you, Do you want us to show it or you want us to move along?
Sir, can you show us?
All right, so I'll all right. Miss Hilton, it's Y.
All right, so M equal.
Okay, so it's Y.
No, I'm saying M is a gradient formula. So M equal Y minus Y1 divided by X minus X1.
So
It's
Y.
gradient for minus Y1 divided by X.
Or basically the Y value.
Yes, if you want
that
to.
you could choose, yeah.
Divide, yeah.
I thought you were going to say the other one. Or basically, you could say Y subtract Y value equal M. You know this one, Hilton? It's the same thing, you know. It's just that you know, it's like you cross multiply it and just leave it like this. Are you there? Are you guys hearing me?
Yes, sir. Yes.
Okay, all right. It seems as if Miss Hilton is having some technical power signal drop. All right, so I will. All right, so basically, I'm gonna go with this formula here. So basically, what happened? You see the 2 point them? We have S and we have T. So we still choose a point. So this is the formula. So let us choose. So let us choose say T, which is what? 6, 6. All right. Then no, we know that M is equal to what? 2/3, right? So basically we use a formula and we say, okay, so it's going to be Y subtract the Y value. Now the Y value of T would be what? Would be 6, not true? All right? Equal the gradient, which is 4/3. So this is the M multiplied by X subtract the X value. So the X value will be what? 6. Any questions? So let me run that again. So it's Y subtract the Y value of T, which is 6, equal M, which is what? 4/3 bracket X subtract the X value. All right. So basically, what we have here is Y subtract 6. And we're going to use distributive law. So 4/3 times x is 4/3.
Sarah look like they don't like this one already.
Me think say gone, you know. And then no. All right, I know, no. They don't really want. They don't want pass, not true. I can't about no pass.
That's why I think the other one is maybe straightforward, but this one would be required to. It just take you to the equation itself.
It takes it directly. All right, so we use the distributive law right here. So 4/3 times x and 4/3 times 6. So we still have y minus 6, and this will be, well, this is going to be 4/3, right? X.
Yes, that remains.
Oops. All right, and then 3 into 3 goes 1, 3 into 6 goes 2, 2 4 is 8.
8.
All right, so y is equal to
4/3x.
And then you'll add 6 to the left.
6 to
and 6 to the right.
So -8 plus 6 is -2.
Is negative. We end up with the same thing.
Which one do you prefer, guys?
I'm going to say the first one.
Not miss.
And you know, so if we had introduced this to them first, you know.
Yes.
You know, yeah. But you know, so to me, honestly, I prefer this. Because it's just,
I prefer it to, sir, because if you don't remember to plug in the things, you would have lost some mark. While it takes you directly to it. So I prefer this as well.
And guess what happened to Miss Hilton? Sometimes you get some values where you can cancel a 3. Is it right here, so?
Yeah, you have to apply.
Suppose the 6 was a 5. That could be a problem.
And you have to go apply the rules of adding or subtracting fractions.
Right.
And all
So
that.
with this no, you go straight away. But we're giving it options, all right, class?
Yes. All right. Very good. So we were at recapping midpoint, and we say that once we're asked to calculate the midpoint of a straight line, then we utilize the formula where we sum the x values, divide by 2, sum the y values, divide by 2, and we end up with our point, midpoint. And remember, we say point, so you must ensure that at the end of your calculation, you have an ordered pair with an x value and a y value. All right, very good. So we're moving on now, sir, to the end of this question.
Oh, it's end, okay. Oh.
No, the end.
The end, okay.
Yes. So they're asking us to calculate the length of the line segment. And this concept was connected to, or it came from Pythagoras theorem. So if you look at the straight line, you realize that based on how it is formed, it forms a slope. So that would be corresponding to the hypotenuse of a right angle triangle. So mathematicians, they made the connection and they saw where this formula was connected to Pythagoras theorem, where we square the lengths of the short sides of the right angle triangle, and we came up with the length of the hypotenuse, or the squares of the length of the hypotenuse. So they connected this with the Pythagoras theorem concept. Hence, we have a formula with some squares in it. So we find the distance, the change in distance with the horizontal movement, changing distance with the vertical movement, and we square the results that we have, and in the end we find the square root. So x2 is 0. X1 is 6. Y2 is -2. And Y1 is 6. Now, as per usual, we're going to simplify, and then at the end, we find the square root. So we're leaving that for last. So we're applying the order of operation now. So we simplify what is in the bracket, then we square. So 0 minus 6 is -6. -2 minus 6 gives us -8. We're now going to apply our exponent rule. So we're going to square those numbers, and then in the end we sum, then square root. So -6 square is the same as -6 times -6, and that gives us a result of 36. All right, and -8 squared, that's -8 times -8, that's 64. We find the sum, then we square root at the end. Sum of 36 and 64 is 100, and the square root of 100 is 10. And we put units at the end, square units, because we don't want to leave it just by writing 10, because we're presenting a length, a dimension. And that would have taken us to the end of this question. So again, this formula is used to calculate the length of a line segment. And it is similar to the Pythagoras theorem, where we square the horizontal distance. That's when we form the right angle triangle surrounding the straight line. We have to use up all of it now. So we use the horizontal distance, the vertical distance, and we carry on with the Pythagoras theorem, basically. That's how this formula came about.
Any questions?
No, sir.
All right. So then I want to take a 5 minutes break.
Yeah, we can. We
Yeah,
can.
we're going to take numerous breaks here. I think we're soon finishing. We only have like 2 more questions to do, and we'll call it a day. All right, but we don't want you to be on the screen so long, and so
Okay, sir.
let's
So
take
remember to
a little water break, a little eye break. So 5 minutes is 1:30, so we return 1:35.
So it's time.
Yes, Ms. Hilton, you want us to do this one without the graph, or
We can look at the one with the graph, and then
all right?
if time allows, we can look at the one which will require us to draw the graph.
Okay. All right. So first of all, guys, all of you, do you have your graph paper with you? Just checking.
Yes, sir.
All right. Okay. Ms. Hilton, did you find any video on this?
Nothing concise.
Concise. All right. All right. So this would require an overview, another overview. So let me explain to you the whole concept or the whole idea of quadratics, or quadratic curves. So we have the quadratic expression, which you know of, right? So this is a little overview. So we usually call this quadratic theory. All right. So basically, all quadratic expression have the general format. Let me see if I can find it. I think it's somewhere. I know I saw this thing somewhere. Give me a second. Okay, I guess I just will type it. It's ax squared plus bx plus c. So all quadratic expression have this general format. All right, a square, a letter, and a number, where a, b, and c are constant. So this is a quadratic expression, but this now is called a quadratic what? Equation. We'll put the equal sign there. It is now called an equation. Now, you guys remember that when we solve these equations, we have two values of x. All right, and there are different ways of solving these equations. So we have different methods solving these equations. Number one, we can solve using factorization method. And the factorization method is the method that is the one where you have to find the two number them. And when you multiply the two numbers, you get the end number. When you add the same two numbers, you get the middle number. You guys remember that? Right. So we can use the factorization method. We can use the formula method. I think I saw it somewhere here. Where is it? Right. That's the formula. And this formula is given in the exam. We can use the formula method, or we have a method called computing the square. And lastly, we have a graphical method. We can actually solve these equations graphically. All right, which essentially is what we're going to do. All right. Now, when you draw a quadratic, let me just go to my program. When you draw a quadratic, right, you will get a curve. All right, as opposed to a straight line. So you're not going to get a straight line, you're going to get a curve. All right. Now the curve can either be a maximum or a minimum. All right. So let me show you what we're talking about. So we have, say, y equals there. All right. So this is a quadratic curve. As you can see, that this curve is a minimum curve. And we used to say that it's a minimum when it shows you a smiley face. All right. And guys, do you notice that this curve here, it cuts? Oops, hold on there, I did something wrong a while ago. Let's look at a new slide. I think I did something wrong. All right, so let's look at this. Y equals x. Where is it? X squared x 3. All right. All right, so this is our curve. As you can see, it's a minimum curve. All right. And you notice that the curve cuts the x-axis at 2 points. Where does the curve cut the x-axis? Who can tell me?
At -3 and +1, sir.
And +1. All right. Now, class, if you were to solve this, if you were to put this equation up here, sir, using the formula, you'll get x equals -3 and x equals 1. And if you're to draw it on a graph paper, it will look like this. And you can solve it by drawing a graph. So essentially what I'm trying to say is that we can solve a quadratic equation by drawing its graph. All right? And it's right here, so right here, so because it's a minimum curve, it's right here, so it's called the turning point or the minimum point. All right. So this point is called the minimum point or the turning point. If the curve was a maximum curve, it will ask you for the what? The maximum what? Point. Not true. Now, another name for the values when x equals to 0 is called the roots. So if you ask for the roots of the equation, you say x equals -3, x equals 1. All right? Okay, I need to draw something, show something. X All right, guys, look at this. Would you agree with me that if I cut the graph in half, what is on the left is also on the right? If I were to cut it,
Yes, sir.
right? So that line is called the line of symmetry. All right. So a line of symmetry is just a line that you draw through the curve that will make the left hand side equal to the right hand side. All right. So these are some basic concepts of your quadratic curve. All right. Okay. So let us go to the question. All right. So by the way, just looking at this, guys, this is this a maximum curve or a minimum curve? Just looking at it.
Repeat, sir.
The question, is it a maximum or a minimum curve?
Minimum.
It's a minimum, yeah. It has a smiley face, not true? So a minimum
Yes, sir.
curve, has a smiley face. What do you think the maximum curve have?
Sad face.
A sad face, right? So it will be opposite, right? So the maximum curve would be like an N. All right. All right. So it says the diagram below shows the graph of the function, whatever, x squared minus 2x minus 3. Oh, by the way, is it in linear graph where we have y equals mx plus c? The c represents what class? In the straight line. What the c represents? Nobody remembers?
Repeat, sir.
In the line y equals mx plus c, what does the c represent? What we just did a while ago.
For the answer a while ago, sir. 6.
No, man. Y equals mx plus c. What does c represent? You don't remember?
Y plus mx.
Let me take you back. Right. So this was a straight line. And we said that c represents what? The intercept on the y-axis. Now, the c in a straight line is also the same c in the curve. All right? So you know that I said that it was what? Y is ax squared plus bx plus c. So for this question here, a would have been equal to 1. So this is, remember, a is always beside what? X squared. And b is always beside what? X. And c is by itself. All right? So c in this question is what? Negative 3. So it means that the curve must cut the y-axis at what? Negative 3. Let's check to see if it cuts at negative 3. Does the curve cut the y-axis at negative 3?
Yes.
Yes. Right. And by the way, do you notice that?
Sir, where is that, sir? At the bottom, sir?
Yeah, man, it's at the bottom here. See there?
Okay. Yes, sir. Yes, sir.
Right. And the curve also cuts the x-axis at which two values? Negative 1.
Negative 1 and a positive 3.
Right. So the curve cuts x-axis at negative 1 and 3. So it tells you that the solution to the question is what? Negative 1 and 3. All right. All right. So let's try to answer the question now. So it says use the graph. The part about the tangent, I'm going to explain to you a bit later. Yeah. Can someone tell me what? Hold on, guys. Let's take this call. Is it done?
Yes, sir.
Give me a minute. I need to take a call here.
All right.
Hello?
So, sir, you need to mute your mic.
Good afternoon.
Mute your mic, sir.
Yeah, man. Come on.
All right. So they're asking us to use our graph to answer a few questions, but I am unable. Sir is the one sharing, so we're just gonna take a little break and allow him to finish with the call. And we are almost out of here as well, guys. I think this might just be our last question.
Okay, miss.
All right, guys, I'm trying to open my document so that I can share my screen because I realized, sir, oh, I think he's back, but I'm
Yeah,
still
man.
okay.
Well, I'm gonna know a while ago, but
All right.
when I took the call, I was trying to answer back, but it wasn't working. So I will resume the share. All right. Okay. How far did he reach?
Sir,
Yeah.
I couldn't see the question, we were waiting on you. That's why I was trying.
Oh.
to find, because I would need to see the graph in order to know the value of A and B.
All right. Okay, sorry about that, guys. But I don't understand because my laptop is different from my phone. So, you know, I'm not sure where I got.
I muted you, because we were hearing you.
Oh, okay. 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 So this is the graph. So it's x squared minus 2x minus 3. You guys remember what a less than equal to x less than equal to b means? What is it talking about? Forget about the a and the b. Suppose I had some numbers there. What did I say it means when we started this class?
Sir, A lesser than what? X is equal to B?
Remember this question here? What did I say?
Let's try.
What did I say? We start at what?
Oh,
Negative 2. And we're in a 3, not true? Right. Right. What does domain mean, class? We have domain and we have range. What does domain mean?
Sir, I number them you go multiply by, sir, so you get your answer.
Right, so okay. Domain. The x values are called what? Domain, not true. So look, the x values are called the what? The domain. And the y values are called the what? The range or the codomain. All right. So the question is asking us.
Sir, now you excuse me, sir. Now you multiply by to get your answer for the range, sir, or the codomain, sir.
Well, yes, we have to use the relation or the formula to get the corresponding y values. So you use a relation, the x values, to get the corresponding y values. All right? You are correct. But you still have to know what domain means. So domain means the x values and the range means the y values. All right, so the question says, use the graph to determine the values of A and B. So A would represent the value, the x value where the graph starts, that's true. And B would represent the x value where the graph ends. So let's go to the graph. So what is A equal to? Where does the graph, which x value does the graph start?
Sir, from the left or right, sir?
Well, I mean,
sir, and then negative 2.
It will be negative 2. So it starts at negative 2 and it ends at where?
Positive 4.
Positive 4. Everybody see that? Look, the graph starts at what? Negative 2 and it ends at what? Positive 4. So that's the value of A and B. So if you're drawing a table, you'll have negative 2, negative 1, 0, 1, 2, 3, and 4. So the answer for the first part is A is equal to negative 2, B is equal to 4. So I'm gonna lie to you, guys, I really feel tired. I'm not sure.
Sorry, I was telling him that this is our final one.
Yeah, man, I feel really, really tired. Not realizing that working from 10 o'clock to 2:30 is like it's like basically you're standing all day working, not true? It's and I can't just imagine you guys. And I must applaud you guys for staying here with us. It shows that you and your parents, you know, have some interest in your future. All right. All right. So A would have been equal to negative 2 and B is equal to positive 4. Right. So then now you just put in those values. All right. So the answers for A, that's 2 marks. Part B, it says determine the values of x for which x squared minus 2x minus 3 is equal to 0. Now what this is saying, you see? What this is saying is where the curve meets the x-axis. All right? What does this mean? It means what does x squared minus 2x minus 3 represent? It represents the curve. All right? And the 0 represents the x-axis. So they want us to find where the curve meets the x-axis at what 2 values? Or in other words, what are the roots of the equation, or what are the solutions? Can you realize that we're actually solving this? We're asking you to work out these values here, so that's what we're doing, you know. So obviously, the 2 values are what, class? Where does the curve meet the x-axis? At what 2 values? At x equals what?
Negative 1 and positive 3.
And positive 3, right? That's it, you know. So x is equal to negative 1 and x is equal to positive 3. All right? So these are the roots of the equation. All right. Now, is it because it's a minimum curve? It have to have a minimum point. All right. Now, how I explain the minimum point to students, you see, is just a point. Okay, imagine that this curve is a road, right? And you're on the road and you're riding a bicycle. Who in here can ride bicycles? Everybody can ride a bicycle?
Me?
All right. All right. So imagine that you're riding a bicycle. This is the road, right? This is the road, you know. And you're riding the bicycle, right? You're riding the bicycle and you're all right. And a question to you. What part on the curve do you start to turn the bicycle? What part?
No, negative 3.
Down at the bottom part, aren't you?
Oh, yeah, true.
Right. So this right here, so you start to turn the bicycle. So this part here is called a turning point. And because it's a minimum curve, we call it minimum point. All right. Now, class, you realize that it says coordinates. So you're talking about an x value and a y value. Can someone tell me what is the minimum point or the turning point for this question? What is it? Right, this is a minimum point. Let me, boy, it seems that you guys are tired. I'm tired too. And today's Friday, not true?
Yes, sir.
All right. You say, boy, you know. But anyways, so right here is a minimum point. All right. So that point is what, class? Which value are we going to write first? The x, then the what? The y. So what's the x value? What's the x value?
Would be positive 3.
See, then
no man.
the x value connecting to that point.
Oh. Connected to that point. Is it negative 3? No, negative 4.
No, Stella. The x. This is x-axis.
Okay.
It will be 1. This one here. And the corresponding
see 1 in a but
what's the corresponding y value?
Negative 4.
It will be negative 4. So this is the minimum point or the turning point. Now, quick question. If they ask you to find the minimum value, listen carefully. You have minimum point and you have something called the minimum value. The minimum value is the y value of the minimum point.
Mm-hmm.
So the minimum value is one number. So the minimum value is just -4. That's it. But if they ask for the minimum point or coordinate, they must give you have to give them the x and the what? The y. You get that?
Or they may ask for the x value at which the minimum occur.
Good. Right. So they could also ask you, what is the value? What is the value of x for which f of x, or whatever they label it as, is a minimum. In other words, class, look here, let me ask a question. When x equals 2, right? All right, imagine that one gunman on the right also. And imagine some gunman on the right, they are 1, then and they are 0. Right? And you are riding your bicycle. Imagine, you look on your bicycle, you know. All right? You're on your bicycle, right? And the gunman start to shoot after you. Question: will the gunman shoot you at the minimum point?
No, sir.
No, because you don't reach the minimum point yet. So I could say when x is equal to 2, when x is equal to 2, you know, I get shot. All right? So guess what happens? You go continue to ride the bicycle, ride the bicycle. And the question says, eh?
When I get shot, you can use the next example.
All right. No, man, a water gun, you know, it's a water gun.
Oh, okay.
It's water gun. It's a water war. War.
Okay.
Yeah, man. Yeah, I just came up with that a while ago. So all right. So when x is equal to 1, no. When x is equal to 1, when it start to turn the curve, no. Guess what? No. At that time, the man start shoot, you know, with the water gun, right? So the question says, what value? Oh, I missed out something. What value of x? Right. What value of x for which f of x is a minimum? All right. So the value of x will be equal to what? X is equal to 1. Because when x is equal to 1, the curve is at a what? A minimum. When x is equal to 2, is the curve is the curve at a minimum? No. When x is equal to 0, is the curve at a minimum? No. It's what the curve is at a minimum when x is equal to 1. Get that? All right. Good.
And what I realized, sir, is that corresponds to the axis of symmetry that you spoke about.
It may go on right now. So, and let me just remind you that the -4 is the minimum value, and right here so is the minimum point or turning point, and in advanced maths they use another word, they call it stationary point. All right. One of the reasons why they call it stationary is that the gradient at that point is actually equal to 0. All right. All right. So lots of stuff to look at. All right, let's get back to this now. So the minimum point is 1 and -4. All right, and let me just throw in this that the minimum value, let me just throw in this, is -4. All right, and let me just throw in, they didn't ask you this, but the value of x when the curve is a minimum is x equal 1. All right, and as Ms. Hilton was saying that the same x equal 1, CMX equal 1 is also the line of symmetry. So basically, what she's saying, you see, that, oh, by the way, what is line of symmetry? If I were to draw this rectangle, where would be the line of symmetry be? Where can I draw a line? Where can I draw a line through this rectangle to cut it exactly in half? Right, that's not true.
Yes, sir.
Okay,
So this is called a line of what? Symmetry. All right. Tell me, where else can I draw the line to get another line of symmetry?
one, sir.
From one corner to the
So
next.
if that's a OA plus OB.
All right. I'm not sure. All right. So yes, in other words, a rectangle has how many lines of symmetry? 2. All right. So that's what symmetry is all about. Quick question. If I were to draw a triangle and I ask you how many lines of symmetry can I get out of this? Is it 1 or 2?
1.
One.
Just 1, not true. And you can only draw it like so, not true. Right. So this is a line of symmetry. So the left hand side is equal to the right hand side. All right. Would you believe me if I tell her that it's my daughter who's in grade 3? That's our math homework, you know. Grade 3, you know. And these are the questions they're asking. How much lines of symmetry can you get out of square and a rectangle? It's amazing what these kids are learning in primary school. Trust me. I even hear they're talking about probability and favorite outcome out of total. You know, Ms. HYLTON? Grade 3, you know. That's what in there. Yeah, seriously. I was listening to her, the teacher, and they were talking about probability, and I said, my word. You know? Oh. But anyways, so where would you draw this line for the symmetrical line? You'll draw it where? Right through this, not true? Right.
Yes, sir.
Because when you draw through this, you get something like that. All right? Now, what they will ask you is, class, what they'll ask you, what is the equation of the axis of symmetry? Just tell them, say, x equal, it sounds fancy, not true? Just tell them x equals what? 1. Sorry, not negative 1. X equals what? 1. So if they ask you what is the equation of the axis of symmetry, it is just x equals 1. All right? Okay. All right, so we're at D now. So D, hold on. So we have A, B, C, and we have D. Now D is a little bit tricky. All right. Now they want us to find the values, the whole number of values of x, for which the curve is less than 1. All right. So basically, sit down on a part of Google. We have to go. They're talking about this one, not true?
The line.
The line, not true?
Mm-hmm.
All right. So this is 1, right? So in other words, this is the curve, you know, and they want to know what are the whole number of values that is less than the line. All right. So this section here, so what are the x values? All right. Now, if you look at this at this point here, you realize that if you're to read off that value, you'll get negative 1 point something, not true? And if you're to read off this value here, so you get 3 point something. All right. So I'm thinking, Ms. HYLTON, I'm thinking that the whole number of values would be, the x values would be. I don't think you're gonna count those, right? It would be negative 1. All right. and 0. This 0 here, so, and then 1, and then 2, and then 3. All right, so you wouldn't count the 3 point something, because the question says what are the whole number x values where the curve is less than 1. All right, so basically it's just these x values here. Let me explain again.
Yes.
So, all right, so this is the curve, right? This is the curve. This is the curve. And what they're saying, they want you to find the values of x that are less than 1. So when it's a less than 1, they're talking about this line here. So suppose it was less than 2. They're talking about all the x values that come under here. So it's less than, not true? All right, if it was greater than, you'll go up. I'm so sorry that we're not going to be able to do the graph of inequalities today. All right, but before I continue, Mr. Hilton, we were talking about keeping another workshop on Sunday. All right, so we could probably pick up on this on Sunday. All right, all things being equal.
Yes.
But we will post information in your various social media network. All right, so let's go again now. Let's go back to the question, by the way. All right, so the question says, use the graph to determine the whole number values. Notice the values of x for which the curve, so x squared minus 2x minus 3 represents what class? It represents the curve, where the curve is less than 1. All right, so let me go to this now. So where the x values where the curve is less than 1, so I'm going to draw my line at 1, and less than 1 would be everything down here. So, and the x values here would be what? Would be -1, would be 0, 1, 2, 3, and yeah, that's it. Because it will be 3. You wouldn't go beyond 3, because this is where they meet between the line and the curve. So it's 3 point something something, but they're not asking you for any decimals or any parts upon number. They ask for whole number values. So that's the answer: -1, 0, 1, 2, and 3. All right. Any questions? All right. I hope you guys are following. All right, so the answer for this would be -1, 0, 1, 2, and 3. All right, last thing now. Last thing for the evening or afternoon. All right, so the question says, use a graph to determine the gradient. Now, class, listen to me. You can't find the gradient of a curve. What you can do is that you can find the gradient of a point that is on the curve. All right? So we can find the gradient of a straight line, but if you're given a curve, you can't find the gradient of an entire curve. You only can find the gradient of a point that is on a curve. So if they're going to ask you to find the gradient on a curve, they have to give you a point. Notice they give you a point, right? It is x equals what? 2. So luckily, to find the gradient at a point on a curve, we draw what we call a tangent. Now, if you did circle theorem, or if you do technical drawing, you know what a tangent is. So a tangent is just a straight line that just touches one point on a curve or a circle. All right? And the point at which it touches the curve or circle is called point of tangency. All right? So if we're to look at this, let me cut this. Is everybody okay? I feel like people say, "Boy, we someone a chat boat."
Yes, sir.
We someone a talk about. So guess what, you know? So in order for us to find the gradient at a point on a curve, they give us a point. And luckily, they actually draw the tangent for us. So we don't have to draw the tangent. All right? So this is our tangent. And this is our point too. All right? So what we're going to do is to find the gradient of this line. So this is our tangent. Can somebody tell me the formula of how we find the gradient of a line? What's the formula? We know it's m, right? M is equal to what?
The line.
Rise and peas or rise?
Rise.
Vertical rise divided by run. No, not run. Run. All right. Okay. So what we do, we choose a right angle that we can count off easily, guys. All right. So in other words, we're not gonna just draw one triangle anywhere we feel like and say, boy, that's not so. See there? We draw a triangle, but then we start to read everything. We can't read it all. So we choose convenient points. Like for example, look at this. Look at that. Lovely, isn't it true? Look at that. Right. All right. I need someone to tell me what the vertical rise is. How much units do we have going up?
4, sir.
All right. Can somebody second that?
1, 2, 3, 4.
So it's 5.
5.
5, man.
Yes, sir.
It's 5 here. So
Right up. We step right at 4. That's why.
all right. No, you have to go where is that? So the rise is 5. And what is the run, class?
6.
See that I just give random numbers? Are you counting?
6, sir.
No, miss, I'm not giving her random numbers.
Count again, please.
So it's 5.
5. Look, 0, 1, 2, 3, 4, 5. So therefore the grade is equal to what? 1. All right. Is the line falling to the right or to the left?
The right, sir.
So therefore it's a plus. All right. So that's the answer.
So, sir, you have to put the plus beside the 1, sir. Just leave the 1 just like that.
You can leave it, but you can leave it.
Okay.
But I must highlight in the fact that you put a plus there to indicate that it's falling to the right. Because if it was over this side, HYLTON, the line would look like that, aren't you? And then this line would be falling where? To the left. And then you have to put a what? Huh?
To the left now, yo.
All right. Okay. Just mute the mic for me, please. Somebody. All right, class. So, any questions? All right. I hope you guys learned a lot today. Any feedback? Anybody want to say anything?
So I was just saying, if you want to remember to post the video on your channel, sir.
Yeah, man, I will do that. All right. Okay. So, do we have 11, 1, and 2, and 3, and 4 represented? We have anybody from 11, 3?
Hi.
Okay. Anybody from 11, 4?
Not sure.
All right.
But
okay.
that is it.
That's it. Yes. Okay, guys. So I don't know if you know, Mr. Lieutenant, I don't know if you mind if I talk your business. Yes, class, Miss.
Auntie, I was here.
Hold on, sir. Let me stop the recording.
Yes, stop recording.
So I'm come from 11-4.